Welcome back, everyone. In this section of the course, we're going to be discussing methods and in particular functions. Let's start by briefly going into the details of methods in this lecture. So we've actually already seen a few examples of methods when learning about object and data structure types in Python. And methods are essentially functions that are built into objects. And later on in the course, we're going to learn how to create our own objects and methods using object-oriented programming and classes. Right now, I want to explore in a bit more detail how to find methods and how to get information about them for built-in objects in Python. In the future, we'll explore creating methods. So let's open up a Jupyter Notebook and quickly discuss methods in built-in objects. Alright, so the first thing I'm going to do is create a simple list and say my list is equal to 1, 2, 3. Now we've already seen before a couple of methods that are useful for a list. So we've seen the append method where we say dot append, and we can append a new item to a list. So then when I see my list here, I get back 1, 2, 3, 4. We've also explored the pop method off a list, pop, and if I just hit empty there, it pops off the last item of the list. And now if I check out my list, it no longer has that last item, number 4. What I want to show you now is a couple of quick ways to get the list of methods in Python for various built-in objects. There's too many methods really to go through them, all of them, in this course. Otherwise, we'd have hours and hours of video of things that you could just explore yourself, and a lot of these methods you don't use that often. So instead, we're going to show you how you can discover methods on your own. The first thing you can do is in Jupyter Notebook, once you've defined that object, hit dot and then hit tab to see a list of all the attributes and methods available for you on that object. Now the other thing you can do as well is actually called the help function. For example, I'm going to hit tab here, and let's explore a function, or a method, excuse me, that we haven't actually explored before. For instance, we haven't actually explored this insert method right here. So I'm going to call insert, and there's two different ways to get help on this. I can do shift tab in the Jupyter Notebook right after this method call, and it will tell me what it is. So it's going to say insert object before index. If you're not using the Jupyter Notebook and you can't do that shift plus tab call, what you could do is call the built-in help function. So if I run the built-in help function and pass in this method, it returns back that same doc string. So if you're using .py scripts, maybe you're in PyCharm or in the text editor, you can use this help function and run this in order to get back the actual documentation on the object. Your third option is to actually view the Python documentation. So let's quickly jump to that. Okay, so here we are at the Python documentation. It's at docs.python.org, so docs.python.org. And in this case, we're looking at the documentation for 3.6. In the future, you may be looking at the documentation for 3.7 or 3.8. But you'll notice here that the first thing we see is a what's new in Python 3.x. So you can click on this and it will take you to this link where it just is almost like a little blog post of the different improvements and things they've changed in the newest version of Python. And as a beginner in Python, there's going to be a lot here that you don't really understand yet. But as you get more and more comfortable with Python, you'll notice that there's a lot of cool things as you begin to kind of update to the latest versions of Python. So here we can see that in Python 3.6, there's this really cool secrets module that allows you to generate secure random numbers for managing secrets. Previously, we saw how there's random number generation, but the secrets module is actually cryptographically secure generation of random numbers. So that's an extra thing they've added in 3.6, and you can explore everything they've added on that link on the main documentation page, What's New in Python. Then there's a tutorial link which kind of shows you the very basics of Python. That may be helpful to you if you want another reference for that. Then there's the library reference and a couple of other links as well as FAQs. So there's FAQs, frequently asked questions, and you can check them out here. General Python FAQs, programming FAQs, design and history, and then a couple more interesting things like using graphical interfaces with FAQs. So I would explore those if you're more interested in that. But the main thing we're here to talk about is this library reference. And it says keep this under your pillow, and for good reason. So when we click on this library reference, this is basically all the information about all the classes, objects, and modules in Python. And a lot of times when you do a Google search, maybe you find a Stack Overflow link. A lot of times in those links, people will link back to the standard documentation here. And as you scroll down, you'll notice it basically discusses the official documentation of everything we cover in this course. So we can see here it starts off with the built-in types that we discussed earlier, such as Boolean types, numeric types, sequence types like list, tuple, range, and then it continues on to talk about exceptions, text processing services, and later on it talks about more advanced things that we're going to cover later on, like collections. Then it talks about the different modules, such as the math module, functional programming module, file and directory access, and you can scroll down, you can see all this useful information about all these built-in modules. So there's a ton of stuff here, and this is kind of the official documentation for a lot of these functions and modules. One thing to keep in mind is that this is not the most readable place to come for answers. You usually want to go to Stack Overflow, where someone has added kind of a nice explanation, but this is the official documentation, and it is pretty good as far as documentation goes for official programming languages. So let's imagine we wanted to go back to that example of using a list object. Well, we could search for it here, and we'll find it here, sequence types list. So there's various sequence types. You click on here for list, and then it says the common sequence operations. And you'll notice that it actually talks about a lot of the operations we've discussed, such as xin, and it gives you the results, so kind of explaining what's happening here, the min, the max, length, indexing, and slicing. It's also all explained here, kind of in a more official way. And if we scroll back up, we can click here on list to go to official list class, and it will take us and explain the various methods, so what sort does when you call it on a list. And it does that for the rest of the object types, and you can also see list implements all of the common and mutable sequence operations. So if you want to know more about those operations, click here on common and it'll take you back to discuss those operations, such as index and count. So this is where you can find a lot more detailed information about the various methods available on objects. As you're a beginner in Python, you won't be visiting this page that often, but as you get more and more advanced, you'll find that a lot of the answers you're searching for are really only found in the documentation. But as you're beginning, I would recommend that you use this help function to quickly find docstrings. And as a reminder, you can use Shift-Tab to quickly get this documentation string on methods and functions. Okay, that's the very basics of methods. Hopefully it was all pretty familiar since we've already discussed methods in the past. Coming up next, what we're going to talk about is functions. We'll see you there. Welcome back, everyone, to the main series of lectures in this section of the course for functions. Creating clean, repeatable code is a key part of becoming an effective programmer. And functions in Python allow us to create blocks of code that can be easily executed many times without needing to constantly rewrite that entire block of code. Currently, if we wanted to have a piece of code run twice or call it multiple times, we would have to copy and paste all the lines in that particular block of code and then call it again. So we would have to rewrite that code. Functions will essentially allow us to do this all within one line. So keep in mind that functions are going to be a huge leap forward in your capabilities as a Python programmer. That also means that the problems you are now able to solve after learning functions can be a lot harder. So it's really important to get practice combining everything you've learned so far, things like control flow, loops, logic, etc., with functions in order to become an effective programmer. Now, I've had the experience of teaching lots of students Python at this point in time. And I often see students that once they start learning functions, they sometimes get discouraged or frustrated because the level of problems they're able to solve with functions tends to be a steep incline. I want you to not worry about that. It's completely normal and very common. And we're going to do our best to guide you step by step and make the introduction to functions a very gradual journey. So keep in mind that you should be patient with yourself when learning about functions because it is going to be a huge leap forward in your skill set, and the best way to learn functions is through practice, practice, practice. Okay, so again, just to kind of visualize what I'm trying to say here is right now, the difficulty of problems you can solve is pretty simple. And throughout the course, as we progressed in Python and learned things about basic data types, we were able to solve some simple problems, and then we learned about things like loops and logic, and we're progressing in Python, and the difficulty of problems we can solve kind of goes along linearly. However, once you learn about functions, you're going to see a steep incline in the difficulty of problems that you can theoretically solve with functions. So I don't want you to get discouraged here when you're going to make a huge leap in a very short amount of time by learning about functions. It's really just about taking on a lot of practice problems with functions. So my rules about learning about functions of Python is to be patient with yourself. Take your time to practice the material. You'll notice that this section of the course actually has more practice problems than almost any other. And to start getting excited about your new skills and start thinking about personal projects, because once you learn about functions, it's really going to open a door into allowing you to start connecting Python to what you actually want to accomplish in the real world. Okay, in the next lecture, we'll begin to learn how to create functions with Python. I'll see you there. Welcome back, everyone, to this lecture on the def keyword, which allows us to create a function with Python. Creating a function in Python actually requires a very specific syntax, including the aforementioned def keyword. It also requires correct indentation and proper structure. Let's begin getting an overview of the Python function structure line by line. So here's the first line of an example function, and it all starts off with this def keyword, essentially standing for the definition of the function. And this keyword just tells Python, hey, what I'm about to write is a function. So you have def, and then you have the name of the function, and you decide on the function name, and you should notice this so-called snake casing. So in general, by convention, Python uses snake casing for the name of the function, and snake casing just means that you're going to use all lowercase letters with underscores between the words. And this is by convention, so this means that in general, if you're looking at someone else's Python script, you can easily tell what's a function because of the use of snake casing. Later on, we'll see that when we learn about object-oriented programming, class calls use camel casing. But for right now, in general, by convention, you should use snake casing, all lowercase with underscores between the words. It will still work if you don't follow snake casing, but in order for your code to be readable by other Python developers, you should use snake casing when naming functions. Then you'll notice we have parentheses here. So the parentheses come at the end, and later on we'll see how we can pass in arguments or parameters into the function, where arguments or parameters are essentially just words saying, take this variable and pass it into the function in order to work with it within the function. And then finally, you'll notice a colon, which indicates an upcoming indented block. Everything indented is then inside the function. So after that comes the optional multi-line string to describe a function. This is called a docstring, and you specify a docstring with triple quotes, which essentially allows you to write a multi-line comment. And this code does not get executed. It's just comment code essentially for someone else who's reading this function, or for you at a later date, that will explain what the function is supposed to do. And now you should start noting that everything inside the function has indented. And then you're going to write the code that you want to be executed every time you call the function. So for example, this is a very simple function. All it's going to do is print hello. So if you were to call this function, you would simply say name of function, and in this case, open close parentheses. So the function's executed, and then it takes whatever code is inside the function and runs it. In this case, it will just print hello. So there's your resulting output. Now functions can begin to get more complex, such as actually accepting a parameter or argument, such as name here. So name is just essentially a made-up variable that I decided to use. You can call it whatever you want here, but we'll call it name. And what we're going to do is use this as an argument to be passed by the user. So notice what happens here. Here I have my function, and it accepts this parameter, name, and what it's going to do is say print hello plus name. So that essentially means that name should be a string, and I'm going to concatenate it with hello. So that means when I call my function here, it says name of function, Jose, and then it'll say hello Jose, which means now I can pass in any string I want into name of function, and it should say hello and then that string. Now typically, however, we're going to use the return keyword to send back the result of the function instead of just printing it out. So far, if we take a look at our examples here, we've just been using print inside of the function calls, like print hello or print hello plus name. In general, you're very rarely just going to have a print inside of a function, because you might as well just call print outside of the function. Instead, you're going to use what is known as the return keyword. And return allows us to assign the output of the function to a new variable. Now we're going to have a much deeper discussion on the return keyword later on in the notebook, so keep that in mind. A really common question is what's the difference between print versus return inside of a function, and we're going to clarify that when we actually start coding out these functions within a notebook. But here, let's just look through a very simple example. I've created a function called add function, and it takes in two arguments or two parameters, num1 and num2. And keep in mind that you can call these variables whatever you want, so it's very flexible in the naming scheme. And then it's going to return the result of num1 plus num2. You should also notice here that return doesn't have any parentheses attached to it, unlike a print function. And so return then allows you to save the result to a variable, which print does not. So that means when I call add function 1, 2, I'm saying num1 is 1, num2 is 2, and so it's going to, inside of the function, do 1 plus 2, which is 3, and since it's using return, I can now save that result to a variable. So I can say result is equal to whatever add function 1, 2 returns to me. So in that case, if I were to later on print the result or use it somewhere else in my code, it's the number 3. So most functions, as I mentioned, will use return. Rarely will a function only print, and we'll show you examples of both use cases in the Jupyter Notebook. Okay, let's start creating functions with Python. I'll see you at the next lecture where we're going to jump straight to a notebook. Welcome back, everyone. In this lecture, we'll jump to a Jupyter Notebook and start creating basic functions in Python. Let's get started. Okay, here I am at a fresh Jupyter Notebook. As a quick note, the lecture notebook that goes along with this is called Functions, and throughout this series of lectures when we talk about things like print versus return, adding in logic inside a function, tuple unpacking, etc., that's all within this singular Functions notebook. So it's a longer notebook that's going to have several video lectures attached to it. Okay, let's get started. As we mentioned, you first have to start off with the def keyword. Notice that it starts highlighting the special syntax behind it, and then we decide on the name of our function. For example, let's have a function called say hello. Then we have open and close parentheses and the colon. And then when you hit enter, you'll notice an automatic indentation, which happens after you click a colon in Python. And basically what that means is anything inside this indented block is going to be called when you execute the function. For example, if I say print hello, run that. Then, if I later on, somewhere else in my code or script, call say hello, open and close parentheses, then it's going to execute the block of code inside this function. That means that if I had more complex code, like a bunch of print statements, hello, how are you, imagine for a second that I wanted this all in 3 lines for some reason, then I no longer need to write those print statements 3 times. Instead, I just need to call say hello 1 time. Now note here the difference between calling say hello with parentheses versus without parentheses. If you call it without parentheses, then it's actually not going to execute the function. Python will just report back that say hello is a function. Keep that in mind, that when we're calling functions, in order to execute them, we have to add on this open and close parentheses. So if you see something like this, it means you're not actually calling the function. You need to add on the parentheses. Okay, so the main point of a function is to execute the block of code, especially when you plan on repeating that block of code. And realistically speaking, we're probably going to take some input parameters or input arguments into our function. So let's go ahead and continue. I'm going to overwrite say hello. And then I'm going to say, let's go ahead and call this name, that it takes in some name parameter. And then it's going to print out, using an f-string literal here, hello, name. So what is this doing? Well, it takes in some argument called name, and then it's going to insert it right here so that it will report back hello name, which means if I call say hello, and I pass in the string Jose, it says hello Jose. A couple of things to note here. Technically, I can call this variable whatever I want. So let's go ahead and show that. I could call this jelly, and then this would have to match up here, jelly, run that, and it looks exactly the same. So typically what you should be doing is just providing variables that make sense to you. In this case, name makes a lot of sense. The other thing to note here is let's imagine I forgot to pass in an actual value. So I just said say hello. Well, in this case, Python is going to complain. And the way to read this error is it will say it's missing one required positional argument called name, which is essentially trying to tell you, hey, we need to know what name is as an argument in order to actually execute this block of code. So how can you fix this? Well, one way is just to provide the value as mentioned. Another way is to provide what's known as a default value. And you do this with an equal sign up here, and you can provide some default value. So what this means is if name is not provided, then we'll go ahead and use this default. And in this case, we'll just say equals, and whatever you want the default string to be. In this case, I literally just put it as default. So make sure you keep running these cells in order to overwrite your old function code. And then let's call say Jose, or say hello Jose. It says hello. And now what we're going to do is leave it blank. Previously, when we left it blank, we got an error. But now that I reran this function definition and run this cell again, it says hello default. So it no longer produces an error. Instead, it will reach in and find the default value for that function. All right, now as we noted in the previous lectures, typically when it comes to a function call, you're not actually just going to print stuff out. Instead, you're going to use the return keyword. So let's see an example of that. I'm going to create a function called def add num, and it takes in two numbers, num1 and num2, and it's going to return their sum. Return num1 plus num2. And one of the most common questions I get from beginning students is what's the difference between saying print in a function versus return in a function? And the main difference is that return, instead of just printing out the results, is actually going to allow you to save them as a variable. So we'll say add num here, and in Jupyter Notebook, if I were to just say something like 1020 add num, notice that I see the result anyways, 30. But because I'm using return, I'm actually able to assign it to a variable. So I can assign it to a variable instead of seeing the result, and then call later on somewhere in my code that result. So let's actually see this between two functions. We will call one print result that takes in two parameters. Let's go ahead and call them a and b this time. And this one just prints out the sum, a plus b. We'll create a very similar function called return result. And this one is going to return a plus b. This way we can actually see the true difference between them. So let's first start off by running this print result function. So I will say print result. I pass in 10 and 20, so 10 plus 20 is 30. And when you run this, notice it prints out 30. You should also notice that unlike before, there is no output cell showing you that a variable is being returned. Instead, it's just printing out the result. So let's imagine that I wanted to actually save the result, 30, to some result variable. What I cannot do, since I'm just using print, is the following. If I say result is equal to print result, then Python is just going to print this out, and it's not actually returning anything to this result. In fact, if I check result and try to run it, I don't get anything back, because the type is none type. Because again, print result is not actually returning anything to be saved. It's simply printing an output and then closing off the function. In order to actually do this sort of thing, where I want to save the variable, I would need to return a plus b. So let's see the return result function now. I say return result, 10, 20. I see 30 is the output. Note that Jupyter lets you know something's being returned by showing you this output cell, just signifying that it's not being printed, it's being returned. And now what I can also do is say result is equal to return result. And now if I call result, it's actually the number 30. So again, just having print here is not going to allow you to actually grab the result. Now that doesn't mean you can't use print and return together. If for some reason, keep in mind it's not super common to do this, that you wanted to see both the printed result and be able to return it, then you could just do something like this. You could say def, call it myfunc, takes in a plus b. It will go ahead and inform the user by printing out a plus b, and it will return a plus b. Now this is not too common to do this. You usually either just return or just print. Most common just return. But if for some reason you find yourself saying, in my large script, I want to be able to kind of view the results as they're coming in, then you could print and then also return, which kind of allows you to get the best of both worlds, so to speak. So I could say result, my function, 10 and 20, run this. Notice that this print gets executed, but then this return also gets executed. So now result is equal to 30. Again, not super common to do this, but when you're debugging sometimes as a beginner, it is useful to have these print statements within a function, so you can see what's going on internally. Now the last thing I want to point out in this lecture is the fact that we were just saying a plus b in the function. But keep in mind, we weren't actually checking what the data types were. So if I called a function sum underscore numbers, it takes in num1, num2, just as before, and it returns num1 plus num2. Nowhere in this am I actually checking to make sure these are numbers. And if you're coming from another programming language that is statically typed, that is to say you have to make sure and define the data type of a variable before you call the variable, then you may not be used to this. Python is dynamically typed, which means I don't need to specify beforehand what data type I expect num1 and num2 to be. That allows you to program a lot faster, but it also leaves you open to possible bugs. Let me show you what I mean. If I say sum numbers, and I say something like 10 and 20, I get the result I expect, 30. But that can get dangerous when I say something like sum numbers, 10 as a string, and 20 as a string. Since these are strings, the add sign will actually concatenate these together, meaning I get the result 1020, which almost looks like 1020, which is not what I was expecting here. And when you're taking user input, it will show up as a string. So recall from the useful operators lecture that the input function returns a string. So that means if you find yourself creating a function that another user will be interacting with, you should probably be making sure to check the type of the data before returning the result. And we're actually going to have a much deeper discussion on this when we start heading towards your milestone project. So keep that in mind for now, and later on we'll show you different ways of having to deal with this and making sure the right data type is being returned by a user. So keep this in mind for now. Later on we'll show you various ways of potentially addressing it. Okay, that's it for now. Coming up next, we'll show you how to add in logic to internal function operations. I'll see you there. Welcome back, everyone, to this lecture on using functions with logic. We already know a lot of logic statements within Python, things like for loops and while loops, if statements and else statements, and so on. So what we're going to do is to begin combining that knowledge with the ability of a function. So let's get started. We're going to start off with a very simple function that just checks whether or not a single number is even, and we'll expand the complexity from there. Let me head back to the Jupyter Notebook. All right, here I am in the Jupyter Notebook. I want to do a quick recall about the mod operator, which essentially returns the remainder after a division, which means if the mod operator is end up equals to 0, then the number is evenly divisible by whatever the mod operation was. So to give you an example of this, if I were to say 2 mod 2 and run this, then the result is 0, because 2 divided by 2 is 1, remainder 0. If I were to say 3 mod 2, then 3 divided by 2, 2 goes in once into 3, and then there's a remainder of 1. So recall that this mod operator just returns back the remainder after division. So for example, if I were to say 41 mod 40, take a second to figure this out. Basically, it should be remainder 1. Since 40 can go into 41 one full time with a remainder of 1. Okay, so how can we use this to check if a number is even? Well, if a number is even, such as 20, then I know that that number, mod 2, should be equal to 0. So essentially, any number I put in here, if I provide the mod operator and it ends up being equal to 0, then I know it's even. If not, then it's not even. So for example, I could do a check like this. I could say 20 mod 2 and check for equality against 0. Because I know if the result of this mod 2 is equal to 0, then I have true, it is an even number. Otherwise, such as 21, odd number, and I do mod 2, set it equal to 0, then that's false. Okay, so let's construct this into a function. That way we can place any number here instead of having to manually type in 20 and 21. We start off with the keyword def. Call your function whatever you want. I will call mine even check. Notice the snake casing here. We have to pass in an argument. I will call the argument number. This is where you have flexibility on what you want to call it. And then what I need to do is inside of this, I need to say the number mod 2 equals 0. And so what this is going to do is if I say something like result is equal to number mod 2 equals 0, I could return the result, run this, and then I can have even check, and so even check 20. 20 is true because this is true, so the result is true. And then I can say even check on 21, and it returns false. 21 is not even. Now, for beginners, it's really common to separate things out into multiple lines like this. But keep in mind, I don't actually need to save this as a result parameter. Instead, I can directly return number mod 2 is equal to 0. So if I paste that in, this is actually the exact same thing. So if I run this again, I get the same results. So again, it's really common for beginners to kind of duplicate lines when really you can just return something that is the Boolean check. So we have a function that can check if a single number is even, and then it returns back a Boolean, true or false, whether or not it's even. Let's go ahead and check inside of a list. So what I'm going to do here is I'm going to start off a new function, and this function is going to return true if any number is even inside a list. Okay, so again, there just has to be a single even number inside of a list, and the list can be as long as you want, and it's going to return true if that happens to be the case. Otherwise, it will not return anything. So we'll say DEF, and I will call this now check even list. It takes in a parameter, and now this parameter is going to be assumed to be a list. So we'll say num list. And what I need to do is I need to loop through each number. So we're going to start adding in logic that we already learned about, like a for loop. So I can say the following. For every number in the num list, and recall num list is going to be passed in by the user, I'm going to have another colon here. And notice how now we have different layers of indentation. I have this first one, which is everything inside the function, and now I'm going to have this second one, which is everything inside this for loop. So, for number in num list, first let me check if I get a so-called hit on an even number. So if that number, mod 2, is equal to 0, well, I'm technically already done. Since I'm just checking if any number is within a list, then the very first time that I hit an even number, I can pretty much return true. So I will say, whoops, forgot my colon there. If number mod 2 is equal to 0, I'll return true. So note here that I'm going to go through every number in the list, and the very first time I get number mod 2 is equal to 0, then I go ahead and return true. And what I'm going to do is say else, and I'm going to use the pass keyword. And pass just means don't do anything. So let's go ahead and look at the logic here. I pass in this list of numbers. I start going through every number in the number list. If I get an even number by saying if true, then I go ahead and return true here. Else, so let's say this is an odd number, I'm just going to pass. I'm not going to do anything. So notice here, return is actually in the middle of the function. It doesn't always have to go at the end. And in fact, we'll show you in just a second how you can have multiple returns inside of a function. So let's first check that this actually works. I'm going to say check even list, and let's pass in a list that has all odd numbers. Notice nothing is returned. Now let's say check even list that has 2 even numbers in it, and it returns back true. There is an even number there. And let's do a couple of edge cases just to make sure this is working. Let's go ahead and have the first number be even. It returns true. And let's go ahead and have the last number be even. And that also returns true. Okay, so it looks like it's working. So what it's doing is just looping through these numbers until it finds an even one, and then it just breaks out of the function and returns true. And in fact, you can think of this return statement as essentially going to break off the entire function and end the function call. Once you call return, that's it. The function's over. It's not being run anymore. So currently, our function doesn't return anything if there is no even number in the list. Let's say we actually want it to return false. How can we fix this? A super common mistake that a beginner would make is they would simply change else here to return false. However, this is wrong. Why is this wrong? Well, I just mentioned you can think of return as essentially breaking out of this function. So why is it wrong to put return false here when it was correct to put return true? Often beginners make the mistake that all the return statements should have the same level of indentation, but that's actually not true. Because look what's going to happen here. We're going to say for number in number list, and then the very first time that a number is not even, we'll say, okay, in other words, just return false. Essentially saying that this if-else statement is only going to be able to check one number because both conditions will immediately return something. So if I were to actually run this, let's go ahead and run this on, let's say 135. So that returned false correctly, but now let's put in a 2 there. It should return true, but notice it returns false because it's essentially only checking the first number since there's a return call on either condition that the first number has. So that means this return should actually not be here. In fact, where should it be? Well, I want to make sure I've already checked every single number and whether or not it's even by the time I return false. So the return false should actually be in indentation with the for loop here. So what this says is go ahead and complete the entire for loop. If this has completed and we never broke out of the function with this return statement, then go ahead and then return false. So let's go ahead and run this and see if that works. So notice 125 returns true. If I change this to 135, now it correctly returns false. Again, a super common mistake beginners make is they think all the returns have to be indented together. But we can see we really need to focus on the logic of what's happening here. We want to loop through all the numbers first, and we can use these pass statements as placeholders to essentially say don't do anything. And that will be very useful when you have a function that needs or requires multiple return statements. Let's expand this one more level of complexity. Let's imagine that we actually want to return all the even numbers in the list. So I don't just want to say true or false, is there an even number? I actually want to return them. So let's go ahead and start adjusting our check even list. So again, what we want to do here is I want to return all the even numbers in a list. And if there are no even numbers, we'll go ahead and just return an empty list. So what do I need to do here? Well, this code may come in handy, so I'll keep it for now. But what I'm going to do is start off with an empty placeholder list. We'll say even numbers is equal to an empty list. And it's very common at the top of a function call, if you intend on returning something, if you don't have it defined as an argument, that you define it up here as some sort of placeholder. So often you'll have placeholder variables at the top of a function. So here, even numbers is essentially a placeholder for what I eventually will return. And so I'm not going to be returning true or false anymore. What do I actually want to return? I want to return the list of even numbers. So what I'm going to do here is I'll still go for every number in the number list. If I do happen to have an even number, I will append it to my even numbers list. I'll say even numbers dot append, and it's called number here. So I'll copy and paste number. Okay, so again, I'm going through the number list. If I attach an even number, I will append it to my list. Otherwise, I don't want to do anything if it's not even. And then just as before, I want to make sure we've looped through every single number in the number list before I return even numbers. So I'll come back here and say return even numbers. So again, the return here is lined up with the for loop because I want to go through the entire logic of the for loop, and only when there's an even number do I do something. And then I return the even numbers list. Let's go ahead and check this out. I'm going to delete a couple of these. So we'll say check even list. If I say 1, 2, 3, 4, 5, I run that, it returns back 2 and 4. Looks like it's working. If I say check even list 1, 3, 5, all odd numbers, I get back an empty list. Okay, that's it for this lecture. Coming up next, we're going to discuss about returning tuples for unpacking with functions. I'll see you there. Welcome back, everyone. In this lecture, we're going to discuss functions and returning multiple items from a function with tuple unpacking. Let's get started. Now recall that we've previously seen we can loop through a list of tuples and unpack the values within them. For example, let me create a list of tuple called stock prices. And what I'm going to do here is the first item will be a ticker and then that stock's price. So we'll say Apple is at 200, and I'm just completely making up these numbers. Then we'll say Google is at, say, $400. And then finally, we'll say Microsoft, $100. Okay, so we already know that I can actually say for item in stock prices, print item, and it prints out the tuples. I also know that I can do tuple unpacking, which means I can actually individually grab the items from these tuples. So I can say for price, or actually for ticker and price in stock prices, print, let's say, just a ticker. Run that, and what it's doing is it's unpacking ticker and price separately, so I can do different things with them, such as ticker, or maybe I can say print price plus, let's say, 0.1 times price. So I want to see what a 10% increase would look like. So I can run that, and now I can see a 10% increase in the prices. Okay, so that's tuple unpacking. Now we've seen how we can do it with a for loop, but we can also do it with a function. So a function can actually return things as tuples, and then we can unpack the result from the function. So let's go ahead and do kind of a more complicated example here. I'm going to say work hours, and this is going to be a list of tuples that has an employee name, let's say Abby, and then the hours they happen to work that particular month. So we have Abby at 100 hours. Let's go ahead and have Billy at 400 hours, just kind of making these up. And then let's have Cassie, whoops, make sure that's a string, at 800 hours. So kind of extreme values here, but they're totally made up. Okay, so we have these work hours over some period of time. And now what we want to do is we want to see who is the employee of the month or the employee of the year. And the way we judge that is by the employee that has worked the most hours. And we want to return not just the employee name, but also the amount of hours worked. So I need a function that can actually then go through these tuples and then see the name and the corresponding hours and keep track of the name that has the most hours. So how can we do this? I'll create a function called employee check, and it accepts this list of tuples, work hours. And then as I've stated before, typically we're going to have placeholder variables when it comes to logic at the very top of a function. So I'm going to have two placeholder variables. I'm going to have a current max, and I'm going to set it equal to 0. And then I'm going to have an employee, let's say of the month in this case. We'll say employee of month, and that's equal to an empty string. Because at the end, I intend to return a tuple. So I intend to return a tuple that says employee of the month along with the current max, which is the current max hours. So why do I have current max equal to 0, and what is current max going to do? Well, what current max is going to do is it's going to start off at 0, and then it's going to compare each employee's hours to the current max hours. And if they beat the current max hours, then I will reset the current max to their value, and I'll reset the employee of the month to this string. So we have to do a for loop to see this. We'll say for, and here we'll do some tuple unpacking, for employee, comma, hours, in work hours, which recall is this list of tuples. What I'm going to do is I'm first going to check if the hours that they've worked is greater than my current max, then I'm going to reset my current max equal to the hours that that particular employee worked. And then the employee of the month is going to be equal to the employee in that tuple. So what does that actually mean? Well, recall that my current max starts off at 0. So immediately, the very first person I see has beat, supposedly, 0 hours. So that means Abby starts off as employee of the month, and my current max hours to beat is 100 hours. Otherwise, I'll simply pass. So let's go ahead and see what happens when we reach Billy. We see Billy, we extract Billy's hours is 400. Is that greater than the current max hours? Well, in this case it is, because Abby only worked 100. So then I reset the current max, essentially the target to beat, as 400, and then I set Billy as the employee of the month. And I keep going throughout this. So then Cassie is going to end up beating Billy's 400 hours, and then she'll be the employee of the month. And what I'm going to do is return this then as a tuple. So again, here's all the code. Let me go out one level of zoom so we can see this all. Going to run this, and let's run our employee check. And I'm going to run it on my current existing work hours. That's the variable we first assigned. And as we suspected, Cassie won. So let's make sure this is working. Let's go ahead and say Billy worked 4,000 hours. So we run this again, employee check, run that, and now I see Billy 4,000. So again, what it's doing here is it's just tracking who worked the max hours and essentially who do we have to beat. And eventually what's going to happen is we'll find out who worked the max hours because no one will start beating this equation right here of hours greater than the current max, which means we never ended up resetting current max and we never end up overriding that employee of the month. So essentially once Billy comes in and he hits 4,000, Cassie doesn't end up beating him with 800, so Billy stays as the assigned variable employee of the month. Now we just saw this returned back this tuple. So what we can do is two things. I can either say result is equal to employee check, and if I take a look at result, it says Billy 4,000, or just as before with the for loop where I said ticker comma price, I can do the same thing if a function returns back this tuple. So it's really common to see something like this. I can say name comma hours is equal to employee check work hours, run that, and note what happened. Unlike before where result, if we see it here, is the tuple, I did tuple unpacking, and now I have the name Billy and hours as separate variables. So I can actually perform tuple unpacking with a function call. Now, a really common error is when you're using someone else's function or a function from a different library that you're not too familiar with, maybe we think that, oh, this function also gives the employee's location. So let's see the result here. Let's say name, comma hours, comma location. Now I know for a fact it doesn't report back the location. If you run this, you get an error. And this is a very common error where it says not enough values to unpack. And very common error to get when you're dealing with functions that you don't 100% know what they return. So you notice here, it actually tells you, hey, expected 3 got 2. Expected 3 is basically what you expected. You expected 3 values, but you only got 2. So how do you actually deal with this sort of error? The easiest way is to just assign everything to a single item and then begin exploring that item. And then you can see, oh, I only have those 2 values and it looks like it was a name and the hours. I don't actually have a third location item. All right, that's it for returning tuples for unpacking. Again, you can review this when we discussed for loops as far as tuple unpacking within a for loop, and you can kind of review this function call in the lecture notebook. If you have any questions, feel free to post to Q&A forums. We'll finish off this lecture series by just creating a very simple function program that essentially shows interactions between functions. I'll see you at the next lecture. Welcome back, everyone, to this lecture on interactions between functions. Typically, a Python script or Python notebook contains several functions interacting with each other. We take the results of one function and often use that as input to another function. What we're going to do is we're going to create a few functions to attempt to mimic the carnival guessing game 3 Cup Monte. And in case you're not familiar with this, it's basically you start off with 3 cups and underneath one of them is hidden a red ball. And then what you're going to do is you shuffle these cups around, have the user guess where the red ball is, and then they're either right or wrong. So our very simple game won't actually show the cups or ball. Instead, we're going to mimic this with the effect of a Python list. So it's going to be a Python list with 2 empty strings and then 1 string that has just a capital O, which will be our ball. And our simple version will also not show the shuffling to the user, so the guess for the user will just be completely random. Our main focus here is to show you how multiple functions can end up interacting with each other and returning objects to each other. Okay, let's get started. All right, here we are in the Jupyter Notebook. To begin, I just want to show you how you can shuffle a list at random in Python. And Python actually comes in with a built-in random module, and we covered this module in more detail later on. But for now, I'll show you just the shuffle function that can come from the random module, and we'll show you how to import it. And we'll talk a lot more about imports later on in the course. But for this case, let's go ahead and make an example list. Let's say it has 7 items in it, and I want to randomly shuffle the list. Well, I can say from random import shuffle. And the shuffle function will actually shuffle a list in place, meaning it doesn't actually return anything. It just grabs that current list and then shuffles it. So we can say shuffle the example list, and then when you call example again, you'll notice that it's been shuffled. So we're going to be using this built-in shuffle from the random module inside of Python within one of our functions. So let's start by creating our simple game. First, I'm going to create kind of our own version of shuffle, which actually returns the example list. Notice shuffle example here doesn't actually return anything. For example, if I were to try to say result is equal to shuffle example and then call result later on, it's actually happening all in place within the example list, so nothing is returned, which means I can't actually do this. So what I need to do is create my own function for this. So say def shuffle, and we can't call it shuffle because that's the same name as the function space and we can't share that namespace. So we'll say def shuffle list, which is going to take in my list. It will shuffle my list, and then it will also return my list. So adding just a little bit of functionality on top of the built-in shuffle. Since the built-in shuffle won't return anything, it just does it in place, and I actually want to be able to return it and use it as a result here. So let's see if this works now. I'll say result is equal to shuffle list. Let's pass in our example. We check out our result, and it's shuffled. And each time I run this, you'll notice it kind of shuffles it in a different way. Perfect. So we have a function that can shuffle this list. So what is our actual game list going to look like? Well, as I noted previously, our game list is just going to be 3 strings, with one of them being essentially a capital O as our red ball, and the other 2 are empty strings. So what the user is going to try to guess is where is this hidden capital O. So eventually what we're going to be doing is calling shuffle list on my list, and then it will shuffle this around, and the O may or may not be in the same spot. Next, we need to create a function that can take in a player guess. So the player, after the list has been shuffled, is going to guess the location, and we won't display where the list is before we shuffle. So what I want to show you is a function called player guess. And this takes in no arguments. Instead, we start off with a placeholder of the user's guess. And the user can guess essentially one of 3 index positions. They can guess it's either index 0, index 1, or index 2. So we start off with an empty guess, and then we'll say guess is equal to input function, and we'll say pick a number 0, 1, or 2. Now, in order to make sure that the guess is actually correct, we could add in some extra code here. Basically, as we mentioned before, we can use a while loop to make sure that the input is correct. So I could say while the guess not in 0, 1, 2, colon, go ahead and keep asking for this input. And then once that's finalized, go ahead and return the integer version of guess. You may be wondering, why are these strings and why are you casting it as an integer at the end? Well, that's because input returns and always returns a string. So even if you type in the integer 0, 1, or 2, it's going to return it as the form of a string, which is why we're checking the string 0, 1, and 2, but I'm returning it as an integer since I will use it to directly index off this list. Let's go ahead and run this so you can see what it looks like. I call player guess, open close parentheses, run this. It says pick a number 0, 1, or 2. If I provide an incorrect value, because of that while loop, it'll keep asking me over and over again until I get either 0, 1, or 2. So if I pass in 1, that's perfect, and then I get the result 1, which I can save. So I could say my index is equal to player guess, run this again, and if I pass in 2 this time, you'll notice that my index is now 2. Perfect. So we just need one more function, which is to essentially combine this list that has been shuffled with the player's guess. So I just need to check that my guess was correct or not. So we'll say check guess, and this is where the functions begin to interact with each other, because I will pass in my shuffled list and I will pass in the user's guess. So that means I should have called player guess and my shuffle list function before calling this check guess function. And so what we're going to do at the end of this notebook is write a little script that essentially calls the functions in the correct order. So we'll say def check guess, and we'll say if my list at my guess index position is equal to a capital O, then I'll simply just print correct. Else, I will print wrong guess, and let's go ahead and tell the user where it actually was by printing out that list. Note, in this case, I don't actually care about returning anything because this will essentially be the last line in my little script. So I have my functions defined, and now it's time to set up a little bit of logic as a final script. So if you're dealing with this in a .py file, it's very common to have a bunch of function definitions at the top, and then at the bottom, you have the actual logic to be called here. So what I need to do is set up my initial list, then I need to shuffle that list, then have the user guess the location, and then I will check against the list with the user guess. So how do we do this? We'll start off with my list, which is an empty string, an O, and another empty string, so the O starts off in the middle. And then what I'm going to do is I will have a mixed up version of this list, and I will call equals shuffle list on my list. So that's step 2. And this is where I'm also going to grab the user guess. So I'll say guess is equal to the result of player guess, and then I'm going to check the guess. So we'll say check guess, and that will pass in the mixed up list along with the user guess. So this is really where the functions start interacting with each other, because I will shuffle and get a mixed list, and then I will get the player guess. And this third function takes the results of those two other functions. And this is what's going to allow you to write much more complex code. The fact that you can have separate functions doing separate parts and then interact with each other later on within another function. So you can see here that I'm actually able to write more complex code because I've been able to compartmentalize a lot of these functions and a lot of this complexity to just certain function calls. So this is really easy to read, and then if I ever have a question on what player guess is or what shuffle list is, I can review by going back up and checking my function definitions. So I can begin creating really complex code that is still actually quite readable. So let's run this and see how it works. So it says pick a number, 0, 1, or 2. Let me just input a wrong number to make sure it's still working. I hit 8, it asks me again. Looks like that's working. Let's just guess location, index position 0, see if I get lucky. I have 1 in 3 chance of getting it right. And it was a wrong guess. So notice here I said 0, 0 is empty string, and it's currently lying at index 2, which also lets me know that the shuffle list is working because my initial list had the O at index position 1. All right, that's it. Go ahead and check out the lecture notebook in case you have any more questions on this. It's kind of set up in a step-by-step manner there, or you can post the Q&A forums if you have any questions. If you're trying to follow along but you're getting errors, make sure you try running our notebook first to make sure you didn't commit a simple typo. Thanks, and I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be discussing 2 functional parameters that you'll definitely be encountering as you look at other people's code and as you begin to look at open source code on the internet. And those are star args and double star quargs, and they stand for arguments and keyword arguments. Eventually, if you work with Python functions long enough, you're going to want a way to accept an arbitrary number of arguments and keyword arguments without having to predefine a bunch of parameters in your function calls. So let's show you what I'm talking about by jumping to a Jupyter Notebook. Let's begin by doing the following. I'm going to create a function, def, and we'll call it myfunc. And what this function is going to do is it's going to accept 2 numbers. number A and number B, and we'll put a little comma here, returns 5% of the sum of A and B. So let's go ahead and do that. What we're going to do is say sum, and we need to pass this in as a tuple or a list here, A and B. So it takes the sum of everything in that tuple, A and B, and then we multiply it by 0.05. So then when I call my func, and let's pass in two numbers, let's say 40 and 60. Well, 40 plus 60 is 100, and 5% of 100 is 5. All right, great. Now the question arises that what if I had more numbers or more parameters to pass in? Notice right now that A and B, these are examples of what are called positional arguments. That is to say that right now 40 is assigned to A because it was in the first position or the first argument, and that 60 is assigned to B because it was in the second position or second argument. And notice that when we want to work with multiple positional arguments in the sum function, we had to pass them in as a tuple. The question I was saying was, what if we want to work with more than two numbers? Well, one thing we could do is assign a lot of parameters. So I could say, well, just in case the person passes in C, I'll have a C there, and I'll set it default to 0 just in case they pass it in. That way, just in case they don't pass it in, it's 0, it won't affect the sum, but they can always overwrite it. And what if they want four numbers? Well, then I'll say D is equal to 0 as well, and I'll have D equal to 0, D here by default. And if I want another number, I can say E equal to 0 here, and we'll say E is here as well. And now I still get back the same result, but I can always pass in more parameters here. So now if I pass in an extra 100, I get back 10 as 5% of 200. And if I want 5% of, let's say, 300, then I end up getting 15 here. And I can keep adding, but you'll notice I'll eventually hit a limit up to E, because if I keep adding in more numbers, eventually I'll say type error, hey, it only takes from 2 to 5 positional arguments, but 6 were given. And this is where we can use that star args. It allows us to set this to take an arbitrary number of arguments. So when a function parameter starts with that star or asterisk, what I'm going to do here is say df my func star args. What this allows me to do is treat this as a tuple of parameters that are coming in. And then I'm going to say return sum of args, and then multiply that by 0.05. And now I can pass in as many arguments as I want. And by default, what Python is going to do is it's going to take all the parameters that are passed in and set them to be inside a tuple. So we're going to pass in, let's say, 40 and 60, and we get back 5. If I add in another 100 there, I get back 10, and I can keep adding in as many numbers as I want here with no problems. And that's basically the whole point of this star args. And I want to just really bring the point home that if I just print out what args actually looks like to this function, it just looks like a tuple here. So all this does, when it starts with this star term, it says, okay, whatever this parameter is, the user can pass in as many as they want, and it's going to be treated as a tuple inside of this function. And that's really useful for a lot of things. You can loop through it, or iterate through it, or sum it together, or do any sort of aggregation function on whatever this tuple that is being passed in. You should also notice that by convention we use args, but this technically is indicated by the fact that there's that star term there. Args can be any other keyword you want. For example, if I say star spam and I say print spam, it has the exact same effect. Args, that word itself, is an arbitrary choice as long as it's followed by this asterisk or star. Now, by convention, you should always use args. Otherwise, someone else is going to be reading your code and scratching their head thinking, why did this person choose spam? So by convention, by pep8 styling, you should always use star with args. Okay, so that's arguments and an arbitrary number of arguments. So you just pass them in now, and you get to have them as a tuple inside your function. So then you could do something like for item in args, print item, and you get back 40, 60, 100. So this allows you, again, pass in as many arguments as you want, and you get this tuple of arguments to play around with inside your function. Similarly, Python offers a way to handle an arbitrary number of keyworded arguments. So instead of creating a tuple of values, what happens is we use **kwargs, which is keyword arguments, and that builds a dictionary of key value pairs. So let's build out a function that utilizes that. We're going to say def myfunc **kwargs, and we will say if, let's make a function, if fruit is in keyword arguments, then I'm going to print something like my fruit of choice is, and then here is where we're going to use .format. And the .format call is keywords arguments. We're going to treat it as a dictionary that's coming in. So just like args here, so *args returns back a tuple, what ** keyword arguments does, it returns back a dictionary, meaning I can grab this, pass in fruits here, and let me zoom out one level so we can see the whole thing, and then I'm going to say else print I did not find any fruit here. Okay, so what does this actually mean? Well, it means the following. I can call my func now and pass in fruit equal to apple. And it turns out that it says my fruit of choice is apple. And I can also pass in some other keywords. Maybe I want to say my favorite veggie is equal to lettuce. And Python is no longer complaining. And that's the power of these arbitrary keyword arguments. What keyword arguments now is if we print it out at the very beginning, it's just a dictionary. We see here that fruit is now attached to apple, veggie is now attached to lettuce, and it allows you to call it any way you want. So just like args up here returned back a tuple, keyword arguments returned back a dictionary that you can then play around with inside your function. So now the user is going to be able to define any parameters you want, and they're going to be able to call them and use them later on inside of your function. And again, kwargs, that is technically an arbitrary choice. What is really indicating this to be a dictionary once it's inside is the use of 2 asterisks here, or 2 stars. So again, I'm going to change this to something that's to make that really obvious. I could say ** jelly, and let's delete all this and just say print jelly. You notice I get back the same result here. So by convention, you should be using kwargs or keyword arguments here, but keep in mind what's really indicating to Python that it's special is these 2 stars in front of it. And now to end our discussion of arguments and keyword arguments is we can actually use these in combination. So I will show you a simple example of that. You can check out the notebook for another example of this, but we're going to accept both arguments at the beginning and keyword arguments at the beginning. And we'll say the following. We're going to print out I would like blank blank, and I'm going to say .format, and we're going to grab args of 0, and then we'll say kwargs of, and we'll expect it to be some sort of food item there. So then I can call my func, and I can pass in as many numbers here as I want, so 10, 20, 30, and those will now be accepted inside of the tuple, and then after that, I can pass in as many keyword arguments as I want. So I could say something like fruit is equal to orange, food is equal to eggs, and maybe animal equal to dog. And then when I run this, what happens is it takes in the args. So let's print these out so we can really see what's going on here. And takes in the keyword arguments as well. Keyword arguments here. It takes in those arguments, takes them in as a tuple so you can do whatever you want with them. It takes in the keyword arguments, sets them as a dictionary so you can use whatever you want with them. and then you can kind of look for things here and then print out whatever you want. And again, this allows you to take in an arbitrary number of arguments that you don't need to define beforehand. And this is going to be especially useful when you begin to use outside libraries. So right now, at your current stage, you're not going to find a whole lot of use cases for args and keyword arguments, but later on, they're going to become incredibly powerful tools for you to leverage in your own code. But for right now, you should just keep in mind that you have a way to accept an arbitrary number of arguments. The only final point I'd like to make here is that because we said args first and keyword arguments, it has to go in that order. We have to have that list or tuple of arguments, and then after that, we have to have the keyword arguments. What we're not able to do is after this, define an argument without a keyword. Otherwise, Python's going to complain. It's going to say, hey, you have a positional argument which is following a keyword argument. It has to be in the same order you prescribed, which was all the arguments first, then all the keyword arguments. All right, that's the basics of args and kwargs. I hope you found that helpful. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be discussing some function practice problems. Learning about Python functions is going to increase your general Python skills exponentially. However, this also means that the difficulties of problems that you can now solve is also going to increase drastically. So this is where, as a beginner in Python, you're going to make a big leap in your abilities. So in order to get comfortable with this leap, we're going to give you some practice problems that allow you to get some practice in converting general problem statements into Python code. Previously, a lot of your assessment test exercises have specifically told you what to do, either to use a for loop or to use list comprehension or use some sort of if statement. Now, we're just going to give you a general problem to solve, and then you're going to have to decide what's the best way to solve it. And a lot of times, there's multiple ways of solving these exercises. So we're going to go through a series of function practice exercises, and then after this lecture, we're going to go through the solutions. Now, there are two options for this material. You can either try out the exercises yourself and then go through the solutions, or you can treat the solutions as a code-along lecture for more guided practice. So if you're still feeling a little bit uneasy with Python functions, you can go ahead and jump to the next lecture and just code along with us for the solutions. Later on in this same section of the course, we're going to have more function practice problems in case you want to try out even more. Okay, so let's go to the notebook to show you a quick overview of what we expect. All right, so here we are at the GitHub page for all the notebooks. Come over to Methods and Functions, click on this folder, and you'll see the Methods notebook and the Functions notebook that relate to the lectures we just went over. And then we have function practice exercises, as well as function practice exercise solutions, which we're going to go over in the next lecture. Now you also notice that there's functions, methods, and homework solutions. Those are going to be for later on for additional practice, but right now, let's check out the function practice exercises. So if we click on that notebook and open it, we get back this. And these problems are arranged in increasing difficulty. So we start with some warm-up problems, and these can be solved using some basic comparison operators and some basic methods. And then we have these level 1, and these may involve if-then conditional statements and some other simple method calls. And then level 2 may require iterating over sequences, usually some kind of loop, like a while loop or a for loop. And then we have challenging problems, and these take some creativity to solve, so they're much harder, and you can kind of treat these as bonus questions. So we don't expect you to solve these challenging ones right away. So you notice throughout the questions, basically, there's the section and some explanation as a word problem of the question, and then an example of what we expect it to look like. So let me show you this example right here. It says lesser of two evens. We want you to write a function that returns the lesser of two given numbers if both numbers are even, but returns the greater one if one or both numbers are odd. So we can see here, both numbers are even, 2 and 4 are even, so it returns the lesser one. However, here, not both numbers are even, 2 and 5, so it returns the greater one. So now you have to think of a couple things. How do I convert these word problems into Python code? How do I check if something is even or odd? And we've already talked about the mod operator with the % sign to check if things are even or odd. And then you want to learn about, well, how do I convert this sort of if statements into actual Python if statements? So that's the idea. We want you to convert these word problems into solutions using Python functions. And we have examples here of what the function call is going to look like, what you should pass in, an example of what you should see back out, either true or false, in this case for this animal crackers problem. And we've also went ahead and filled out some cells for you to code in. So those are the warm-up problems. Then we have the level 1 problems that you'll go through. And then we have the level 2 problems as well. And then all the way down towards the end, we have the challenging problems. You can kind of treat these as a bonus. You don't have to go through them yet. But try your best on all of these problems. Now, I want to make it very clear that we understand you're still beginning and this is basically your first time using Python functions. So if you're feeling a little uneasy, if even these warm-up problems are really hard for you, go ahead and jump to the solutions lecture and watch me code through these problems. It's really going to help you a lot. And don't feel like you're losing out on your chance to test yourself, because later on, if you come back to this, we have functions and methods homework, which is going to be even more function practice for you later on in the course. So we can go through these function practice exercises as code along if you want to. So feel free to jump ahead to the solutions, treat it as a code along because you're going to have more practice in your homework later on. But if you want that extra challenge, if you're feeling up to it, I would really recommend that you download this notebook, try your best to go through it, and then see how you did against the solutions. Okay, we'll see you in the next lecture where we actually begin to code along through the solutions. In this lecture, we're going to code along through the solutions for the previous function practice problems. Let's get started. Okay, let's begin with this warm-up section. And this one was called lesser of two evens. We wanted to write a function that returns the lesser of two given numbers if both numbers are even, but returns the greater if one or both numbers are odd. So here we have our function, and it takes in a number a and a number b. The first thing we want to do is probably check if the numbers are both even, and that way we have an if statement. So we'll say if a mod 2 is equal to 0, so that is to say when you divide a by 2, does it have a remainder of 0, indicating that it's even, and the same for b. b mod 2 is equal to 0. So if this statement happens to be true, so if this condition is true, that means we have both numbers are even. So I'm going to say here both numbers are even. And in this case, when both numbers are even, we want to return the lesser of the two numbers. So we'll say the following. We're going to say if a mod 2 is equal to 0 and b mod 2 is equal to 0, let's check the greater number. If a is less than b, we're going to say result is equal to a. Else, result is equal to b. And off of this, what we're going to do is say else. So now, one or both numbers are odd. And in this case, we want to return the greater. So we're doing the exact opposite here. If a is greater than b, say the result is a, else the result is b, and then all the way at the end here, we can return the result. Notice the indentation here. All right, so this is one way of solving this problem, just using a bunch of if and else statements. So let's run this and confirm that it's actually working for us. So lesser of two evens, looks like it's returning 2 here. Lesser of two evens, if one of them is an odd number, it's returning 5. Let's make them both odd just to check. And now it returns 7. Great. So this is a viable solution for this problem. However, we can actually clean up this code a lot more. And in fact, there's a way we can run this chunk of code automatically, and that's using the min function. Previously, we saw how the min function can actually return the minimum value of a list. But if we take a look at what happens with minimum function when we pass in two numbers, such as 10 and 20, it actually returns back the minimum of the two numbers that you're comparing. And it works with just two numbers. If you want more than that, you'll have to pass in a list. But it also works the same with the max function. So then it returns the max, either 20 here when you pass in two numbers. In which case, all I need to do is the following. I can say result here is equal to the max of a comma b. And I can then say here, result is equal to the min of a and b. So we've been able to clean this up even further. And now if I run this, let's check to make sure we get back the same results here. So I get back 2, and I get back 7 when I rerun those cells. Perfect. And in fact, we can take this one step further. We can actually have multiple return statements inside here, because once you say return and it gets executed, the function will stop. So instead of saving these as results and then waiting until the very end to return your result, what we could do is just say return min ab over here, and then say return max AB over here and delete this last one. So then what's going to happen here is your function's going to go along and it says, hey, if both the numbers are even, go ahead and just go straight to returning the minimum value between A and B. Else, then go straight to returning the maximum value of A and B. And this is probably the most efficient way to do this problem. We could make it a little sleeker, maybe try to put it all in one line, but this right here is a better solution than what we saw at the very first run. And this is what you're going to see in the notebook. All right, the next question in the warm-up section was this question called animal crackers, where we wanted to write a function that takes in a two-word string and then returns true if both words begin with the same letter. So here I can see level-headed and llama both begin with L, so we return true. Crazy kangaroo begin with different letters, so we return false. So let's build this out. And we're going to do a similar thing as last time. We'll build out all the logic and then see if we can make it a little sleeker by using some keywords. So the first thing I want to do is actually grab the two words. So I'm going to create a variable called wordList and set it equal to the incoming string. And to grab the two words, I can use split. And now I should have a list of the actual two words. So let's just print out wordList so we can confirm this. So if I run this, now I see that I'm getting back a list of two words. And what I want to do is check, is the very first character in this word matching to the very first character in this word? So I could say that my first word is equal to wordList at 0, and my second word is equal to wordList at index 1. And then I want to return is first 0, meaning is that first letter of the first word equal to second 0. So is this first letter equal to the first letter of second? So now when we run this, I get back true, and I get back false here. And we can take out this print statement now to see just the Boolean results. Now we could actually edit this a little bit. In fact, notice here how I'm essentially making two index calls, 0 and then another 0 here, and then 1 and another 0 here. So what I could do is not even bother with this assignment, and instead just grab wordList itself and replace it for first here. And then I could grab wordList 1 here and replace it for second there. And now this is the exact same thing, except it's now using a double index call. So when I run this again, I get back the same results. Something to notice here that I'm not actually checking is just in case these two letters, right now they're both capitalized, and we're assuming they're both capitalized, but maybe one of them is lowercase, and I'll show you what I mean by that. Let's imagine we have crazy cat with a lowercase c. If I run this, it's going to return false, even though they are starting with the same letter. In that case, what I could do is lowercase my text, before the split. So I could say text.lower, and then after that, call the split. So I could either do that in a new line, but Python actually allows you to kind of tack these on one right after the other. So I'm going to do lower and then do .split on this. So now let's run this again. And now we can see that it confirms true because it's making everything lowercase before it actually does the split. And we can see that by printing out that word list. And if I run this again on crazy cat, I notice here crazy has now been lowercased. And it would have worked the same way had we used upper, because then it would have just uppercased the cat there. So it would have confirmed capital C matches capital C. All right, so that's the basics of that animals crackers problem. All right, our last warm-up problem is a little more math-based, and it's called makes 20. And we wanted to know that given two integers, return true if the sum of the integers is 20, or if one of the integers themselves is 20. If neither of these is true, go ahead and return false. So let's check through these three cases. First, we need to check, is the sum 20? So you can say if n1 plus n2 is equal to 20, return true. And then we can have elif cases for the other ones. We can say elif n1 is equal to 20, return true. elif n2 is equal to 20, return true. And if none of these happen to be true, then we can just return false. So when I run this code and I check it, it looks like it's working. So 2 and 3 is false, 20 and 10 is true, And if we do one that sums up to 20, 10, and 10, that also returns true. But as I previously mentioned throughout the course, if you're already checking if some Boolean statement return that actual Boolean, then what we could do is put all of this on a single line. So how do we actually do that? Well, notice it's just a bunch of Boolean checks here, so we can use these comparison operators along with a logical operator such as OR. So all we actually need to do in one line is say return n1 plus n2 equal to 20, or n1 equal to 20, or n2 equal to 20. So let's check out how this is the exact same thing as all this code that we just wrote here. We're saying check if this Boolean condition is true, or this one happens to be true, or this one happens to be true. If none of these happen to be true, then we return false. So this one single line of code is doing the same thing as all of this. And we can check it out by running this, and we get back the exact same results. All right, that's it for the warm-up problems. Coming up next, we're going to go over level 1 problems. We'll see you there. Welcome back, everyone. In this lecture, we're going to go over the solutions for the practice problems that were under level 1. Let's open up that Jupyter Notebook and continue. Okay, the first problem was this Old MacDonald problem where we wanted you to write a function that capitalizes the first and fourth letters of a name. And there's two different ways we're going to show you how to do this. One is with the capitalize method, and then the other is with the upper method. We haven't really shown you the capitalize method yet, except we added a note here that basically what capitalize does is it grabs an entire string and it uppercases the first letter in that string. So let's do it first with .upper, and then we'll show you how to do it with .capitalize. First, we want to grab the first letter. So I'm going to say first letter is equal to name at 0. And then I want to grab the characters in between. So we'll call these in between characters. And those are going to go from name at index 1 all the way up to, let's say, index 3. And then we want to grab the fourth letter. So we'll say fourth letter is name at index 3. And then finally, the rest is going to be name from index 4 onwards. So let's see if this works. We're going to just return first letter with in between with the fourth letter plus rest. So let's see if we actually get the same result there. Okay, so good. We get back MacDonald. Now what we want to do is uppercase the first letter, and then we want to uppercase the fourth letter. And now when we run this, we get back MacDonald. So this is how you could do this with uppercase. Using just indexing and slicing, you separate it out, uppercase what you need, and then concatenate it back together again. But you can also do this with the capitalize method. And the capitalize method is going to allow you to do fewer slices. So what we could do is kind of separate it out into halves. So we'll say first half of the name is going to be from name from the beginning all the way to index 3. So that's going to be basically the Mac part. And then the rest of it, that second half, and it's not really an even half, I should say probably second part, is going to be from 3 all the way to the end. And then what we could do is the following. I can say first half, and instead of calling upper, I'm going to call capitalize. Capitalize. And then I will concatenate that with the second half and capitalize that. And now when we run this, we get back the same results. So that's how you could use the capitalize method instead of the upper method. And basically what that does is it grabs two strings, this lowercase Mac and this lowercase Donald, and it uppercases the first letter or character in those substrings and then concatenates them together. So that's the Old MacDonald shown two different ways. Next, we have Master Yoda, where we're given a sentence. We want to return a sentence with the words reversed. So in order to do this, what we need to do is a couple things. First, we need to actually get a list of the words. So we're already quite familiar with that now. We can say word list is equal to text.split. And now I need to somehow reverse this list. And we actually know various methods of doing that. So let me show you what I mean. I'm going to say text.split is the word list, and then I'm going to slice the word list in steps from all the way from the beginning to the end in -1, and that's actually going to be the reversed word list. Whoops, let's make sure we don't use a keyword there. Reverse word list, and let's return the reversed word list and see what happens. So notice here, I get back home am I, and then with Master Yoda, I get back ready are we. Now we do want an actual string instead of the list itself. In order to join this list, we can actually use a method called join off a string. So let me create a couple of cells here, that way I can explain how the join method works in case you haven't seen it before. Let's imagine I have a list here of a string A, B, and C. And I want to join this together. So I will call this my list. What you end up doing is you create a string. Here I'm going to have a string of 2 dashes. And then off of the string you say dot join, and then you pass in my list. And what this does is it takes the string you have here and it's going to use it to concatenate as a fill-in between every item in this list. So if I just have a space here, it puts a space between A, B, and C. If I have maybe a bunch of O's, then it's going to put a bunch of O's in between A, B, and C. So a lot of times when you want to join things together, such as words in a list, you can either have it as an empty string, just a blank string to single quotes right next to each other, A, B, C, or we can have a space here and it joins together A space B, C. So in order to actually get this back as a string sentence, what I could do is the following. Instead of just saying reverse word list, I could say single quote space single quote dot join the reverse word list. And now when I run this, I get back the actual string itself. Home am I, and then ready are we. So that's a little introduction to the join method in case you haven't seen it before. Finally, we're going to discuss the almost there, and that was given an integer n, return true if n is within 10 of either 100 or 200. So the way we can do that is by taking note of ABS. So ABS returns the absolute value of a number. So we're going to return and check for the following. We want to check if 100 minus n, the absolute value of that, is less than or equal to 10. So we want to check that, but we also want to check another situation. So we're going to wrap this in parentheses to kind of state that's one thing we're checking. Or we want to check if the absolute value between 200 and n is less than or equal to 10. And then finally, we can return this. So we're just checking, hey, is 100 minus number the absolute value of that? Basically, the difference between that number and 100, is that less than or equal to 10? Or is the difference between that number and 200 less than or equal to 10? And when we run this, we get back the correct results. So this is false, this one's true, and then this one's also true. Okay, that's the basics of level 1. Introduced a couple of new things here, mainly the dot join method and the absolute value function. In the very next lecture, we're going to go over the level 2 problems. We'll see you there. Welcome back. In this lecture, we're going to go over the solutions for the level 2 problems in the function practice problems notebook. Let's get started. All right, so here we are at level 2 problems. The first problem we had was find 33, which was given a list of integers, return true if this list or array contains a 3 next to a 3 somewhere. So here we can see 3 and 3 are together, so we say true. Here the 3's aren't connected anyway, so we say false. And again, here 3's aren't connected together, so we say false. So if we basically get 2 3's in a row, we know to return true. So to do this, we'll do the following logic. We'll say for I in range from 0, and we actually don't want to go all the way to the end of nums. We want to go to the length of nums minus 1, because we want to go up to the second to last digit so we can check the very next digit. If we went up to the last digit, there would be no next digit to check, which is why we're going to say for I in range from 0 to length of nums minus 1. So this is part of the trick already. And we can say if nums of I is equal to 3 and nums of I plus 1 is equal to 3, then return true. Otherwise, what we're going to do is return false. So notice what I'm doing here. I'm going to run through a for loop that goes through every single index position in this list up to the second to last one. And then what we're going to do, then what we're going to do here is check that number and the number right next to it. So nums of I, and the number right next to it is nums of I plus 1. And if they're both 3, then we're going to return true. If we go through this entire for loop and we never execute this return statement, then we know there are no 3's together and we'll return false. So let's run this and check it out. We're going to copy this, paste it here, run that, and we get back true. Let's check one of the false ones, see if it also works. Put that in, run it, and we get back false. Perfect. Now, the other alternative we could do that it doesn't look as nice as this if statement is to say if nums of I sliced to I plus 2 is equal to the list 3, 3. This is actually the exact same thing as before. It just is, in my opinion, a little less readable, but it is technically a little sleeker because you're just doing one slice and one comparison instead of two comparisons. So all this is doing is grabbing slices at a time and comparing them to this sublist 3, 3. All right, let's move on to this problem called paper doll. So for this paper doll problem, we wanted to say, given a string, return a string where for every character in the original, there are now 3 characters. So essentially go along and create 3 of these characters. So 3 H's, 3 E's, 3 L's, another set of 3 L's, and then 3 O's. And this problem is actually not so bad once you figure out the trick is to start with an empty string and then to keep concatenating to that string. So I'm going to say result starts off as an empty string. And then for every character in that text that I pass in, I'm going to grab my current result, so that current string, and I'm going to add on that character times 3. The other thing I could do is say character plus character plus character. So times 3, or 3 characters concatenated together, that's the same thing. And then at the end of this for loop, outside of it, I'll just say return result. And that's actually all you had to do. So the main trick here is realizing that you can continually concatenate to that string. The next question was called Blackjack, which is basically using the Blackjack card game as a base for the given problem statement. We were given 3 integers between 1 and 11, and if their sum is less than or equal to 21, we just return their sum. However, if their sum exceeds 21 and there's an 11, we get a chance to reduce the total sum by 10. And then finally, if that sum, even after adjustment, exceeds 21, we return bust. So let's check this out. The first thing we'll do is just actually check if their sum is less than or equal to 21. And we can do this by saying if sum of A, B, C is less than or equal to 21, return back that sum. We'll say sum of A, B, C. So sum is a nice built-in function you can use. Alternatively, you could have just said A plus B plus C. So that's the same thing as passing in this list here of A, B, and C. So we'll be using the sum keyword because it's a little more readable. All right, the next thing we're going to check is the second case, which is where we actually have an 11 there. So remember, when there's an 11, we get to reduce the total sum by 10. And then we actually check if it exceeds or not. So something we can do is say the following. Elif there's an 11 in the list A, B, C. So if there's an 11 in there, and the sum of these 3 put together is less than or equal to 31, because remember, we get to reduce the total sum by 10 when there's an 11 there. So basically, we get to check it against 31 this time. Then we get to return the sum. So then we can return the sum of this, ABC, except we're going to subtract now 10 from this. So this less than or equal to 31, basically what we're doing is now, instead of checking less than 21, because beforehand we're able to reduce the sum by 10, that means we get to check against 31. So the other way of doing this is saying sum of ABC minus 10 is less than or equal to 21. So those are the same things. And it's up to you which logic you prefer, whether you prefer to take the sum, then subtract 10, and then check if it's less than or 21, or if you just like to do the check against 31. So that's technically the same thing there. Finally, if that doesn't happen to be the case, then this person has busted, so we return bust. So now when we run this, we get back 18, bust, and then we run that one more time, we get back 19. Okay, let's go to the next problem, which is summer of 69. We wanted you to return the sum of the numbers in the array, except ignore sections of numbers starting with a 6 and extending to the next 9. So every 6 will be followed by at least one 9, and we return 0 for no numbers. So what does that actually mean? Well, we can see here 3 different examples. Here we have 1, 3, 5, so there's no 6s or 9s there, so we return back the sum of all of them, which is 1 plus 3 plus 5, which is 9. Here we get back 4, 5, and then we have a 6, 7, 8, 9. So 6 through 9 here are going to be ignored. So that's the summer of 69. We're ignoring it because, let's say, nothing got done there. So then we just add 4 plus 5, and we get back 9. Here we get 2, 1, and then we have a 6 and a 9. So these two numbers plus anything in between gets ignored. And then we see 11 there, and then we get back 14. And we also noted that every 6 will be followed by at least one 9 when you're given in this list. So you don't need to worry about some sort of weird edge case where you just have a 6 and then you're waiting for a 9 that never comes. Okay, so let's get started on this. The way we're going to do this is start with a running total. We'll say total is equal to 0. And I'm also going to create a Boolean value called add. And I'm going to set it to true first. And I will say for num in my array or in my list, while add is on, so while I'm still adding, while that's true, and we start off with true, if the current number is not equal to 6, then I'm going to take my total and I will add num to it. And then I will break out of here. Else, what I'm going to do is set add equal to false. And then lined up with this while loop, what I'll do is set up while not add. The other way to say that is while add is not equal to true. If num is not equal to 9, then I'm going to break. Else, I'm going to add, set that back equal to true, and then break here. And then finally, after all of this, outside of this for loop, I'll return the total. So let's run this, and then we'll break down the explanation. Okay, so it looks like we got 9 here, that looks good. We got 9 here, that looks good, 4 and 5 together, ignoring all this. And then summer 69 here, we just get 2 plus 1 plus 11, which is 14. So what's actually happening here in our logic? Well, we have our total, which is 0, that makes sense. And we have this Boolean condition called add, which is equal to true. And basically, by default, I'm going to assume that I'm going to keep adding all the numbers in this list or in this array. So then I'm going through the array, and I'm saying, okay, for every number in the array, if my add statement is true, then I'll do the following check. If the number doesn't happen to be 6, I will say, take the total, add the number in there, and then I'm going to break out of that loop. So I'm going to break out of this in closing loop, which is the while loop, which brings me back then to the for loop, and I continue along. Then I'm going to say else. So let's say the number was 6, so this doesn't happen to be true. Then I set add equal to false. So in that case, now I'm just waiting for the 9. So I'm right now in the summer 69, and I have to keep going waiting for the 9. So I'll say while not add, if num is not equal to 9, then I will break out of this while not add. Else, I will say add is equal to true, and then I will break. Okay, so this one's definitely a little tricky because we're using breaks here, and we have a nested loop situation. We have a for loop with 2 while loops nested in there. So the key thing to notice here is that this break is only connected to the while loop it's in. And these breaks are only connected to the while loops they're in, which will bring you back to this for loop so you can continue on with the numbers. I would say this is definitely probably the hardest problem, I would say, in this entire challenge, as far as the ones that aren't specifically challenging problems. But even I think that this summer 69 is probably even harder than this first challenging problem. Okay, in the very next lecture, we'll finish off our discussion by going through these challenging problems and their solutions. We'll see you there. Welcome back, everyone. In this lecture, we're going to finish off by going over the challenging problems. And we're going to start off with spy game. Now, spy game at first seems similar to the get33, except in this case, we want to write a function that takes in a list of integers and returns true if it contains 007 in order. And that actually doesn't mean in consecutive order. And we show that by the second example here. So this first example you can see here has 007 or 007 in order, so it returns true. Now you'll also notice on the second one it has 2 zeros showing up before a 7, which also means true. So this 007 doesn't have to be consecutive, it can also work like this, 007. And here you can see we have 700, so that returns false. So let's see how we can actually approach this problem. We'll say spy game function, and it takes in some list of numbers, num. So right off the bat, we know we're going to have to go through each of these numbers and do some sort of check. So something that might be good is say for num in nums. And right now we can say pass just as a little placeholder while we think about this. I want to check if 2 zeros show up before a 7. So there's lots of ways we could do this, but one way is to set up a code list. And our code list is going to be 0, 0, 7, and then some extra string. So we'll have X there. And what we're going to do is we're going to go through every number in this list, and if we hit the first item in this list, we'll go ahead and just pop it off. So what I mean by this is if I say for num in numbers, if my current number is equal to the first item in code, what I will say is equal to the first item in code, so code at index 0, I'm going to take that code list and pop off that first item. So what does this actually mean? It means as I'm iterating through this list, I'm checking the number and saying, hey, is this number equal to the first number in this code list? So you can imagine for this first case, eventually I hit the 0, and I say, yes, I have a match, 0 and 0. So what I do is I pop off the index at 0. So that means I pop off this 0. So then the next iteration of code looks like this. We have 0, 7, and then some string, x. And then if I get another match, then I pop off again. So I will get 7, and then the string x. And then if I pop off one more time, meaning I matched 007 in consecutive order, then I'll just have a list of length 1. So notice here we have our length is equal to 1. And you could also just check if length is empty or something like that, but we'll do length equals to 1, just so it's easier to understand. So then here, I'll just return is the length of my code after running that for loop equal to 1. So let's walk through this one more time because the code is a little weird at first, but if we break down the logic, it'll make sense. I have this code list, and it has 007 and some extra string. And I'm going to go through every number in this list, and I'm going to check, is that number equal to code at index 0? If that's the case, then I'm going to pop off the first item in code. So it's first going to start off at 0. That means now code is equal to 07x. So I keep doing my for loop, and I check, hey, do not have this number equal to code at 0? So that's this 0 now. If that's true, then I pop it off, and now my code list looks like this, 7x. So I keep going around until I see that 7, and I say, hey, if 7 is equal to that first item in that code list, this 7 right here, then pop off that 7. And if I'm able to go through this entire for loop, and I finally, since it's a list of integers, I have a string here, and it's going to be a list of length 1, then if length of the code is equal to 1, then I know I had 007 or 007 in order. So we can check this out by running this. Let's grab some of these examples, run them. We get back true. Let's run the second one. We should also get back true. And let's run the third one, which should bring back false. Okay, so again, this one's a little more challenging because we had to use an outside data structure and use logic in order to figure out how best to find those consecutive numbers. There's tons of different ways you could have approached this one. Feel free to share your other methods in the Q&A forum. Okay, the next question was count primes, which was to write a function that returns the number of prime numbers that exists up to and including a given number. And by convention, we'll treat 0 and 1 as not prime. So how do we actually approach this? Well, we're going to start off by saying def count primes, and we pass in some number. So that's going to be the integer itself. Now, since we're treating 0 and 1 as not prime, we might as well have a quick check for them. So I'm going to say if that number that the person inputted is less than 2, meaning it's 0 or 1, or it's a negative number, we'll just return 0. So this is our check for 0 or 1 input. Now, if we've not returned yet after this check, then we know we're dealing with a number that's 2 or greater. Now, 2 itself is a prime number, and I want to make a list to keep track of prime numbers. So here's what I'm going to do, and this is kind of a clever trick, which is what makes this challenging. I will start off my list called primes with the number 2 in it. And then I'm going to set a variable x equal to 3. And what I'm going to do is I'm going to keep adding onto x until I hit the input number, and we'll check if x ends up being prime or not. So let me show you what I mean by that. So we already know that if we've gone past that if statement, then we're dealing with 2 or greater. And we have here a list. Let me zoom in just a little bit here. We have in a list to store our prime numbers. And then we have some sort of, we'll say x is some sort of counter that's going up to the input num. And we'll say while x is less than or equal to that input number, I'll say for y in range from 3 all the way up to that current number x, and then we'll take step size of 2. The reason we're taking step sizes of 2 here is because even numbers beyond 2, we already know those will not have a chance of being prime because they're even numbers. They're all going to be evenly divisible by 2. So what we're doing here is we have x, which is this counter. And then we're saying, okay, kind of a sub-problem here. We need to check if x itself is prime. So x is going through every number up to the input number. And then here we need to check if x is prime. So we'll say for y in range from 3 to x in even steps, because we only want to check odd numbers there, if x mod y is equal to 0, then we know we don't have an even number there, or excuse me, we know we don't have a prime number there. So what we're going to do is add 2 to x, kind of add 2 to our count, and we'll break out of this for loop. So this for loop, all it does is this checks if x is prime, because it's going through every number in range 3 up to x. Remember, x is going then through every number up to the input number. So this is checking if x is prime. We say if that x number is ever evenly divisible by one of these numbers in its range, then we know it's not prime, and we're going to add a count 2 to kind of hop ahead past that even number, and then we'll break out of this for loop because we're done checking if x is prime. However, if we're able to successfully go through that entire for loop and we don't actually end up breaking out of it, then we have a prime number somewhere. So what we want to do is take that prime number and append it to our primes list. And this is what makes the problem challenging, is that you can use a for else statement. And this is something that's unique to Python. Note how my else is actually lined up with my for instead of with my if here. And that's because I have a break inside of my for. So what this else is saying here is if I went through this entire for loop and I never broke, then this else statement is going to execute. And again, this is something unique to Python, the for else. We haven't talked about it before, which is what kind of makes this a challenge bonus problem. So if that happens to be the case, meaning we checked and we never broke out of this, so x actually is prime, we're going to take our primes list and we'll append that x number to it. And then we jump ahead past that even number, so we'll say x is now equal to x plus equal to 2. And after this whole thing's done, we're going to print that list of primes. and then we'll return back what the question's actually asking, which is the length of how many prime numbers there are. So let me quickly go through the logic here one more time. We first check for 0 and 1 input by saying if number is less than 2, return 0. Then, since I know I'm dealing with a number of 2 or greater, I'm going to start off my count of my prime numbers with the number 2 in there, so I can start off with 3. And the bonus of starting off with 3 means I can use a step size of 2, and that's indicated here from range 3x2, as well as when I'm adding 2 to my count of x, if I end up breaking out of one of these for loops or I trigger that else statement, because then I'm skipping along all those even numbers, which is why we have plus equals 2 here, and why we're taking a step of range 2 there. And then what we're doing is we're going through x all the way up to that number, going to check if that x is prime, and if it is prime, meaning we never broke out of this, we're going to append it to the prime list, and then add 2 to our count, and keep going through this while loop. Then we're going to print all our primes, and return the length of primes. So we run this, and we say count, call count primes here on 100. We get back that list of primes, and we get back the number 25. Now there's a clever trick you can add to this, and the fact is that you actually don't need to check every single number up to x here. Instead, recall that you're actually already storing a list of primes here. So you could say is for y in, and instead of saying range 3x2, you could say for y in primes. So that makes use of those prime numbers you're collecting as you go along. So now it's saying for y in prime numbers, check if x mod one of these prime numbers is equal to 0. And that's how we can do another x is prime check there. Keep in mind, this has to do more with math, I believe, than coding. So if this is a struggle for you, don't worry about it too much. This is more of a challenge math problem than a challenge programming problem, I would say. Especially since this is a challenge problem, it's a bonus, and you're still not quite at the skill level where you can tackle 2 problems at the same time. One is a really hard programming problem, and the other one is a really hard math problem. So this is combining both of those, which is what makes it really challenging. If, however, you really like these sort of problems, what I would check out is the Euler project. That's EULER project. And it has a ton of these types of math problems that can, in general, only be solved with coding. So definitely check out that website if you happen to really enjoy this one. If you are totally lost in this one because of this heavy math, don't worry about it. That's why it's a challenge problem. Okay, so that's it for these 2 challenge problems. We also had a just for fun problem. It wasn't really a real, it was just printing out functions to take in a single letter. So I'll bring that over from the notebook itself. So this was a just for fun, and it's basically where you had to kind of invent a dictionary that would print out these letters. And because of that, we're only able to say A, B, C, D, E here as examples. Everything else you would have to kind of manually print out. But it's just an idea of how you could print out actual graphics using Python code. And we'll get an idea later on using your first milestone project so you can have graphics that you can interact with a user. That'll be for your tic-tac-toe board that'll be printing out later on. Okay, if you have any questions, feel free to post to the Q&A forums, but we'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be discussing lambda expressions, map, and filter. Lambda expressions are a way to quickly create what are known as anonymous functions, basically just one-time use functions that you don't even really name, you just use them one time and then never reference them again. To understand why this would be useful and in what context you would use this, we first need to talk about the map function that's built into Python, as well as the filter function that's built into Python. So let's open up a Jupyter Notebook, talk about map, talk about filter, and then we'll discuss lambda expressions. Let's get started. Okay, so we're back here at our Jupyter Notebook. The first thing we're going to do is check out the map function. You can see here, right when I type map, I'm getting some syntax highlighting, so it's green, and that indicates to me this is a built-in function. And as we know, we can use Shift-Tab to check out the documentation string. And you can see here, it expects a func, and that's short code for function, and then some sort of iterable object. You can expand this, and it'll explain a little more about what it does. But the best way to actually realize what it does is to just show you. Since we know it's expecting a function, let's quickly create a function. We'll use our def keyword, and we're going to create a simple function that just takes in a number and returns its square. So we will define a function called square, takes in a number, and it returns that number to the power of 2, or the square of that number. Now let's imagine I have a list of numbers. And my numbers are 1, 2, 3, 1, 2, 3, 4, 5. And what I want to do is I want to apply the square function to every single number in my nums list. Well, one way I could do that is use a for loop, but that may take a while and it's a lot of code. Instead, what I want to do is take advantage of that map function. So the map function, what you end up doing is you pass in the function that you want to map to every single element or item in this list. So then we can say my nums. Now notice what happens when I just run it like this. I get back this kind of cryptic statement which says, hey, you have a map at this location on your computer. So this is a memory location. This by itself isn't super useful. What we need to do is actually iterate through this. So what I can do now is say for item in map print item. And what this does is it generates applying this square function to every single item in this list. So 1 to the power of 2 is 1, and 2 to the power of 2 is 4, then 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So that's one way to quickly iterate through this. Another way you may want to use this is if you actually want the list back, you can call the built-in list function on your map, and then pass in square and my nums here. And now when you run this, you get back the actual list, 1, 4, 9, 16, 25. And these functions can actually be a lot more complex than just this simple square function. So let's show you a function that works with strings. We'll call this function splicer. And it takes in a string. I'll say it takes in my string. And what it's going to do is it's going to say if the length of my string mod2 is equal to 0, well, that means it has an even number of characters in that string because the remainder after dividing by 2 is equal to 0. And in that case, we're going to return the word even, or the string even. Else, we're actually just going to return the first character of that string. We'll say my string 0. So this is a little more complex of a function than we saw up here, but it's going to work just the same way when we map it. So let's create a list of names. We'll say Andy, Eve, and let's say Sally. And then we're going to, after we call list, map our splicer function to our names. We run this, and now we get back even for names that have an even number of letters in them, and we only get back first letters for names that have an odd number of letters to them. And now you can see the flexibility. You can pretty much do any function you want as long as it's going to successfully take in the argument or parameter that you pass in with this list or with any iterable object. So that's how you can use the map function. Something that I want to make really clear here when you're using the map function, notice how I'm passing in square and how I'm passing in splicer. I'm actually not calling them to execute inside of this map because map by itself is later on going to execute them. So that means when you pass in the function here to map, you do not add in the open and close parentheses. Instead, you just pass in the function itself as an argument. And that's a really important detail to note here. Otherwise, if you do this, you'll end up getting some sort of type error. It's going to say, hey, you're missing one required positional argument. Or it's going to say something like, hey, we're not able to apply splicer calls to names. And that's because we just want to pass in the function itself. We don't want to execute the function. We'll let map do that for us. That's the map function. And now let's learn about the filter function. The filter function returns an iterator yielding those items of the iterable for which when you pass in the item into the function, it's true. And that just means that you need to filter by a function that returns either true or false. Let's create a function that returns either true or false. We'll create a function called checkEven, and it takes in a number. And all this function does is it returns back whether or not this is an even number. So we will say, as we've seen many times before, return num mod2 equal to 0. Because when you divide this number by 2, the remainder, if it's 0, then that means that it's even. If not, then we return false, and it's an odd number. Then I'm going to create a list of my numbers, and we'll have it be 1, 2, 3, 4, 5, 6. Now let's imagine I only want to grab even numbers from this list. or I only want to grab numbers that pass some sort of condition based off a function that I previously defined. What I could do is use the filter function. And it's very similar to what we just saw with map. But what map did is map applied this function to every element in that list. Filter, instead, what it's going to do is it's going to filter based off this function's condition. So this function, when you're using a filter, has to return a Boolean, has to return either true or false. And then what we're going to do here is say apply check even to my nums. And again, just like last time, if you run this by itself, it's going to say, hey, you have a filter object at this point in your memory. Instead, what we want to do is either transform it to a list so that we get back only the even numbers here, or we can iterate through it. So we can say for n in filter apply check even to my nums, print out n, and we see here we've printed out 246. So you can either transform it to a list or iterate through the results on that, the results that this filter function is generating. Now that we've learned about the map function and the filter function, we can learn about lambda expressions and see in context why they're really useful. So what we're going to do is show you my favorite way of explaining the lambda expression, and that's by converting a function step by step into a lambda expression. And then we'll actually explain more formally what a lambda expression is. So I'm going to take that square function we did earlier, or at least a really similar function to it, and define it here. So notice what I have. I have def square num, and I say the result is equal to num to the power of 2 return result. Now if I call square, let's make sure I spell that right. If I call square on a number, I get back the square. What I'm going to do now is slowly, step by step, turn this into a lambda expression. So first off, let's see how we can simplify this. Right now, I'm assigning result equal to num to the power of 2 and then returning that result. What I could do instead is just get rid of this assignment and return num to the power of 2. And if I run this, it's the exact same thing. And what I could also do is actually write this all on one line. And typically, you wouldn't do this because it's bad styling and not by convention, but Python won't actually complain here, and it will let you run this all on one line. Now, we're almost in the form of a lambda expression. In fact, we can easily convert this into a lambda expression through the following manner. A lambda expression is also known as an anonymous function, and the reason for that is because it's some functionality that you intend to only use one time. Because of that, we don't actually give it a name, nor do we use the def keyword. So instead of a name or the def keyword, we replace that with the keyword lambda. So I'm going to get rid of this and just say lambda here. And then we say lambda num colon, and the return keyword is basically, we get rid of that because it's assumed that we're going to return whatever's on the other side of this colon. And there we have it. This is now a lambda expression. And I could, if I wanted to, assign it to square, run that, and then I see square still working. So let me make this to another number. We see 5 to the power of 2 is 25. Now I just mentioned that lambdas are anonymous functions and you typically don't name them. So a lot of times you're not really going to be doing this square is equal to some lambda expression. Instead, you're going to be using it in conjunction with other functions, such as map and filter. So we look up here, and we see that earlier when I was using map, I was passing in this square function and applying it to every item in this list, my nums. Now that required me to actually define square fully here. But what if I only intend to use this one time? Do I want to take up space by defining this function here and then having to call it here? What I could do instead is just call a lambda expression. And this is where lambda expressions really begin to shine, and this is why you would use them. I could just say map lambda num colon num to the power of 2, and then apply that to a list of numbers, such as my nums, and then cast that to a list, and we get back the same thing here. Every number in the my nums list has now been squared. Now that we've seen how we can use lambda with the map function, let's quickly check how we can use it with the filter function. So up here we saw that we were filtering using this check even function. So let's start by converting this check even into a lambda expression. We'll come over here, we'll remove the name and the DEF and replace that all with the lambda keyword. Remove that parentheses and then get rid of return here and put it all in one line. And now we have our lambda expression. Then we're going to pass this into filter along with the list of numbers we want to filter. And to get the results, we'll pass this into list. And then we run that back, we'll get back 2, 4, 6, only the even numbers. And lambda expressions can be used for a variety of things. Let's imagine that you wanted to grab the first character of a string. So let's create a list here. Well, we actually have the names list. So we have Andy, Eve, Sally, and we only want to grab, let's say, these first letters. What I could do is map lambda, and I can take the incoming name, and I want to return back only the first character at index 0 of names. And you can call this whatever you want. It doesn't have to be name. It could be x here or any other variable, just like for any normal function. And let's pass this to a list so we can see the results. And there we go, AES. Now let's imagine I wanted to reverse the actual names. What I could do is say : -1, and then that will reverse the names, just as we've seen with slicing before. You can even pass in multiple arguments into a lambda expression. However, keep in mind that not every function that we've seen up here, for example, this check even or splicer or square, not every single complex function is going to be directly translated to a lambda expression. So you should really only use lambda expressions when you can still easily read it if you were to come back to your code later. And as you get more and more experience with Python, you'll be able to quickly realize what a lambda expression is doing. But in the beginning, it's going to be a bit tricky at first. So if you ever struggle with trying to convert a normal function to a lambda expression, just try using a normal function instead. All right, that's the basics of map, filter, and lambda expressions. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to talk about nested statements and scope. We've gone over already how to write our own functions, and we've even gotten a little bit of practice with them. However, it's important to understand how Python deals with the variable names you assign. When you create a variable name in Python, that name is stored in what's called the namespace. And variable names also have a scope, and the scope determines the visibility of that variable name to other parts of your code. So if you've ever wondered why you've gotten some errors that say something like, this variable is not defined, we're going to explore why that happens and how to fix those errors in the future. Let's get started. Okay, the first thing we're going to do is with a little thought experiment, and then we're going to explore the results. Right now, I'm going to say x is equal to 25, and below that, I will create a function. It's going to be called printer. Make sure you don't call it print, otherwise we'll overwrite the print function. But all this does is it sets x equal to 50, and then it returns x. So let's run this. And now I want to ask you, what do you expect to happen when I say print x? Do you expect to see 25 or 50? So when I run this, I get back 25. And if you had the intuition that it's going to be 25, that's great. And if you had the intuition that it's going to be 50, don't worry, that's exactly what this lecture is here to explain. What I want to show you is if I say print, printer, open close parentheses, so I'm actually running the result of printer and returning the x here, then I get back 50. So when I print out x, I get 25, and when I print out the result of printer, I get 50. So this is quite interesting, but the question we want to answer is, how does Python actually know which x assignment I'm referring to in my code? Am I referring to this x is equal to 25, or am I referring to this x is equal to 50? And why doesn't this reassignment seem to affect the assignment up here when I later on asked for print x? And this is because the idea of scope allows Python to understand and have a set of rules to decide which variables you're referencing in your code. And these rules are a LEGB rule format. So LEGB stands for local, enclosing function locals, global, and built-in. So let's take a look at this. So this is the LEGB rule, and this is essentially the order that Python is going to look for variables in. And it starts off by checking out the local namespace. And these are names that are assigned in any way within a function, such as df or inside a Lambda call. And they're not declared global in that function. And later on, we'll see what we mean by declared global that uses a global keyword. So first, Python's going to say, hey, if you call that variable, is it in my local namespace? Then it's going to check for enclosing function locals. And these are names in the local scope of any and all enclosing functions from inner to outer. So you can actually have functions inside of functions, which you're going to see in just a second. Then it looks for the variable, if it still can't find it, in the global namespace. And these are names assigned at the top level of a module file or declared global in a DEF within the file. Then it looks in the built-in namespace. So these are names that are pre-assigned in the built-in names module. Things like open, range, list, str, syntax errors, etc. Built-in keywords in Python that you see have those special syntax highlighting rules to them. Let's explore what each of these looks like: local, enclosing function locals, global, and built-in. We'll start off with an example of local. So an example of local would be something like inside a Lambda function. If we were to say num num to the power of 2, this is an example of a local variable. So num right here is local to this Lambda expression. Let's now see an example of enclosing function locals. So we'll go ahead and just comment this out. In order to show you an example of enclosing function locals, we first need to create a function and then put a function inside of it. So I'm going to say name at the very top of this. Notice the indentation and say this is a global string. Then I will create a function called greet. It takes in no arguments, and inside of this I say name is equal to Sammy. So I'm overriding that name variable here. And then inside of this function I'm going to say hello, and I'm going to say, hey, print hello concatenated with name. And then I'm going to call hello, and then I'm going to call greet. All right, so there's a lot going on here, especially since there's a function inside a function. So let's break this one down. Here, I have a function called greet, and what it does inside of it, it sets the variable name equal to Sammy. Then inside of the greet function, so notice how all of this right here that I have highlighted is inside of greet because of the indentation. We have def, then the hello function, and inside the hello function I ask, hey, print out hello name. And right now we have name defined twice, up here as a global, and then over here as an enclosing function local. And after we define hello, inside of greet, I'm actually going to call and execute hello, and then I will call greet. So let's see what happens when we run this. We get back hello Sammy when I actually execute greet. So what's actually happening here? Well, when I execute greet, and in fact we can put this in a new cell so that's a little more clear what's happening. So greet's kind of separate. That greet call is separate from the definition of greet. When I call greet, what happens is I'm calling and executing the greet function. It assigns name equal to Sammy, and then it defines this function hello, and then it calls the function hello. So when you call greet, internally, it's creating this variable name, it's defining this function hello, and then it's executing this function hello. This is going to follow this LEGB rule when we want to figure out, well, what name are you referring to? So first off, we look in the local namespace. So the local namespace, as we just discussed, is within a function. So here in the function, def hello, it's going to say, hey, did I define name anywhere? If it can't find it, then it goes to the next level. So after searching local, we go to enclosing function locals. So we have this enclosing function because this function is inside of this function. And then here we do find that name has been defined. It's equal to Sammy. So that's the one we choose when we finally execute hello here. And that's why you see hello Sammy. Now let's see what happens if I were to comment this out. So now I've commented out Sammy, and if I run this again and I run that again, now I see hello, this is a global string. So what's happening now? Well, we're going through the same rules. We first look at local. So when we execute hello here, this hello function says, well, I got to figure out what variable name is. I don't see it defined locally, And now, since this is commented, I don't see it defined in the enclosing function. So then I'm going to go to the next step, which is to look globally. And there it is in the global level. This is a global string. And global is defined by basically having no indentation. It's all the way to the left, either in your script or in your Jupyter Notebook cell. And because it found it in the global namespace, it now says, hello, this is a global string. Let's see what happens if we uncomment this and we say name equals Sammy. So I want to kind of label these right now. This is the global. This one right here is enclosing. And let's make a local one. So local is going to be name is equal to I'm a local. And now when we rerun this to redefine this function, and I call greet, it gets back, hello, I'm a local. Because when you execute hello, that executes this function right here, which says, hey, Python, figure out what is this name variable assigned to. And it immediately finds it in the local namespace right here, name, I'm a local, so that's what it uses. As you can comment these out, it'll look in the next level, meaning the enclosing functions. If you comment that one out, it will then look in the global namespace level. And the only level above global is the built-in function level, which would be something like a built-in function as length. So you should always be careful not to overwrite these built-in function names, and they're always indicated to you with syntax highlighting. And if you're not sure, if you're able to call help on it, and you see some stuff pop out, then it's definitely built in because it already has that information. Finally, to close off this discussion, what we're going to do is look back at our original thought experiment, this assignment of x25 at the global level, reassigning it at the local level, returning the local assignment, but still being able to print out both when we wanted to. We could print out the global one, or we could return that local one and print that out as well. So we're going to discuss local variables as well as the global keyword. So we're going to show you an example of that thought experiment again. We'll say x is equal to 50. And I'm going to create a function that takes in x, and it's going to print, using f-string notation, x is x right here. So let's run that, and let's see what happens when we call function x. It says x is 50. Perfect. Now, also inside this function, I'm going to reassign x locally. So this is a local reassignment. And then I'm going to print I just locally changed x to, and then we'll insert x right there. And make sure your x variable is lowercase here if it was lowercase there. So now we rerun this cell to redefine that function. And now I see x is 50, I just locally changed x to be 200. Now, outside of this, what happens if I print x? Well, I get back x is 50, even though inside of this function I reassigned it to be 200. And this is because this reassignment is only happening in the local namespace inside of this function. It's not going to affect anything at a higher scope. So this is what scope really is. It's the fact that when you declare variables inside of a function definition, such as what we've done here, those variable names only have a scope local to this function. So that's the scope of this variable x right here when we assign it inside of this function. We have an x here floating around in the global space, but this local reassignment, its scope won't be able to extend outside to another level, which is why, after all, we're still able to print out x here as 50. So let's imagine you're in a situation where, for whatever reason, you actually did want to grab this global x and reassign it to be 200. How could you do that? Well, in that case, we won't actually accept x as a parameter. Instead, what we're going to do is inside our function, at the very first line, we're going to declare the global keyword here, and then say x. And what this does is, instead of passing in x, we're going to declare a global x, and that tells Python, hey, I want you to go to the namespace, jump to the global level, and grab the x variable there. And then what I want you to do is anything that happens inside the scope of this assignment, it's going to affect that global x. So we're going to grab that global x, report what it is, we're going to do a local reassignment, except now it's on a global variable, meaning it will have an effect to this guy up here, 50. And then we're going to print, I just locally changed global x to some other value. Okay, so let's run this again, and I'm going to, instead of having this be 200, I'm going to make it super obvious that we're changing it by saying new value. So x used to be a number 50. I'm going to, when I call this function, reach into the global namespace, grab that x, report back what it is, change it to the string new value, and display, hey, I just locally changed global x. So let's run this. And I'm going to create a couple more cells here using Alt-Enter just so we get kind of a clean slate. So I just ran this, and let's see what happens when I actually call it. So right now I just defined the function. I haven't actually executed it yet. So when I right now say print x, I still have 50 there. Let's see what happens when I execute the function. It says, hey, x is 50, as we just saw, and now it's reporting back, I just locally changed the global x to the string new value. And now let's see what happens when I print out x. It says new value. So using the global keyword, you're able to reach out into that global namespace, and then your local assignments do affect that global variable. Now, because of the power of this global keyword to do that, in general, especially if you're a beginner, you should avoid using that global keyword unless absolutely necessary. Instead, what you should be doing is if you want to grab that global variable and then affect it, you should take it in as a parameter, do the reassignment, and then return the reassignment as an object itself. So let me show you why you would want to do that. So now that I ran that, if I print out x, x is still 50, and then I'm going to say func of x, and then I will say x is now equal to func of x. So x is 50, I just locally changed, and I should have deleted this, it's no longer that global variable, but technically, now when I call x, it's been reassigned to the string new value because I returned x and I reassigned the global level x using that function. And in general, this is a much better path to take than using that global keyword. So even though this combined with this is the same thing as the global keyword, it's much cleaner and much safer because you'd have to know that you want this reassignment to take place somewhere else in your code. It's quite dangerous to have the reassignment take place with the global keyword because as you use larger and larger scripts and you have separate scripts interacting with each other, you may accidentally overwrite a global keyword inside of a function without ever knowing it. And that makes it a lot harder to debug. It's a lot easier to debug something like this because there's a clear reassignment happening here where we specifically grabbed that global x and said, hey, now make that equal to the output of whatever this function is. And later on, when you have your first Milestone 1 project, that's the pathway we're going to recommend taking for dealing with certain objects in that global namespace. Okay, definitely a more complex topic, but hopefully it allows you to build an intuition of nested statements and, more importantly, the scope of variables. Thanks, everyone, and we'll see you at the next lecture. Welcome back, everyone. We're going to continue to test your skills with methods and functions in what we've labeled a homework assignment, but really you can do it whenever. It's a notebook, methods and functions homework. So let's go ahead and do a quick overview of the notebook in this lecture, and in the next lecture we'll go through some example solutions. Let me hop over to that notebook. Okay, here I am in the functions and methods homework notebook. So this is 08-functions and methods homework. And so basically what we want you to do is answer the following questions, and they're pretty much all in the form of a function. So you'll notice this first one here says, write a function that computes the volume of a sphere given its radius. So, in case you don't know that formula, it's 4/3 times pi times r cubed. And what we've done here is essentially we have these placeholder functions with just a simple pass statement. And it's your job to fill out this function, and then you should be able to check it with the second cell and make sure you get a corresponding correct value. So then go ahead and fill out here this function called vol or volume, whatever you want to call it, and then run it to check. Okay. Next one is to write a function that checks whether a number is in a given range, inclusive of high and low. So you should include that high and low number. So for example, we're going to take in the number, low and high, and what we should be able to do is check if 5 is in the given range between 2 and 7. And however you want to return the results is okay with me. If you want, you can print out a statement saying 5 is in the range, or you can print out something like 10 is outside the range. Alternatively, you can just return a Boolean, so it could return true or false. See if you can write it both ways, one that returns this print statement and one that returns the Boolean. Next, we want you to write a Python function that accepts a string and calculates the number of uppercase letters and lowercase letters. So an example string could be something like, "Hello, Mr. Rogers, how are you this fine Tuesday?" So we have hello capitalized, M capitalized here, Rogers capitalized, and then T capitalized. And what we want you to do is essentially go through this string and then count the number of uppercase letters and print it out, and the number of lowercase letters and print it out. Now there's two methods that will be very useful for this, which is the isUpper method and the isLower method. You can call this on a string or a single letter and check if it's uppercase or lowercase. I'll let you to figure out the best way to run that. And again, here it is, the function with a placeholder. And when you run this, it should put out an output, something similar to this. Okay. Next, we want you to write a Python function that takes in a list and returns a new list with unique elements of the first list. So for example, here we have the list with repeated 1s, 2s, 3s, and then a 4 and a 5. So we just want the unique elements. So 1, 2, 3, 4, 5. And if you recall from our previous lectures on data types, there's a specific data type that could be helpful for you in order to grab the unique elements from an iterable object like a list. So I'll kind of leave that to you to figure out, but essentially the output should look something like this, just the unique elements. And note, we want it in a list form. After that, we want you to write a Python function to multiply all the numbers in a list. So you have a sample list, 1, 2, 3, and then here -4. And essentially what should be happening here is the output will be 1 times 2 times 3 times -4. So in this case, 1 times 2 is 2, times 3 is 6, times -4 is -24. And this should be able to work for a list regardless of how long the list is. So this should work for a list of 2 items up to, a million items. So make sure your code is robust in that sense. The next question is to write a Python function that checks whether a word or phrase is a palindrome or not. And in case you're not familiar with what a palindrome is, it's a word, phrase, or sequence that reads the same way backwards or forwards. So single words can be something like madam or kayak or race car. If you read those backwards, it's the same thing. Or it can be a phrase like nurses run. And as a quick hint, when you're dealing with the phrases, you may want to check out the replace method in a string to help out with dealing with spaces. You can also Google search how to reverse a string in Python, because essentially what you're trying to do is compare a string against its reverse. So some things to keep in mind. And then finally, this one's a little hard, but we want you to write a Python function to check whether a string is a pangram or not. And there's going to be a couple of things you'll have to check out, including the string module, which isn't exactly something we covered in the previous lecture. So here we want you to expand your capabilities, essentially being able to do a Google search or a Stack Overflow search to compare or grab the full alphabet in Python. And we gave kind of a link here for you to check out, which is the string.ascii_lowercase. So see if you can Google search and figure out what this is doing. But essentially what we want you to do is a pangram is a word or sentence containing every letter of the alphabet at least once. So for example, here we can see the quick brown fox jumps over the lazy dog. And again, notice here we set a hint, look at the string module. This string.ascii_lowercase, if you check it out, and we kind of showed you here what it does, it actually is a string of the entire alphabet in lowercase. One last point I want to make here is, for the sake of simplicity, go ahead and assume there's no punctuation passed into the string here. So again, don't worry about the edge case of punctuation. Assume that the string can have both uppercase and lowercase letters, but no punctuation. All right, thanks, and we'll see you at the next lecture where we'll go over the solutions. Welcome back, everyone, to this lecture where we're going to be going through the solutions for the methods and functions homework exercises. Let's get started. Okay, here I am at the functions and methods homework notebook. The first task we had to do was write a function that computes the volume of a sphere given its radius. So this is a really common task you may have to do if you work in the STEM field or science or technology, where you have to transform essentially a mathematical equation into actual code. And this one's a pretty simple example, so let's go ahead and work through it. What we first do is take the 4/3, so I'm going to, in parentheses here, do 4/3 to make sure the order of operations ends up being correct. Then I'm going to multiply it by pi. Pi can actually be imported from the math module that we'll learn about later with Python, or you can just estimate it with 3.14. So if you wanted to, you could say import, or say from math, import pi, but in this case, we'll just say 3.14. And then we'll also take the radius, and we need to cube it. So for exponents, that's going to be 2 asterisks there. And we could just say something like result is equal to this, and then return result. But this is actually duplicating a step we don't need. We don't actually need to save this as a variable. Instead, we can simply just say return that. So let's go ahead and check to make sure this worked. I run this, and I get back the correct results. Okay, let's move on to the next one. Next one was to write a function that checks whether a number is in a given range, inclusive of high and low. So lots of different ways you can do this. The main thing I wanted you to be aware of was the fact that you're probably going to have to use the range function, and it's inclusive of high and low. And if you recall, the range function is actually exclusive of high. So if I take a look at this, for example, if I say for item in range 0 to 5, print item, notice it goes up to but not including the last number here, 5. So this is actually inclusive of the first lower bound and exclusive of the upper bound. So that means if I'm going to use range and I want inclusive of high and low, I may have to do something like +1 here, and we'll see that in just a second. So let's go ahead and check this out. I'm going to make use of the in operator keyword. And recall, the in operator is a really useful operator. We actually cover it in the useful operators lecture, which just checks for the presence of something in an iterable. So I could say 5 in range 0 to 10, and it's going to be true. Now, if I said in range 0 to 5, that's going to be false, because recall that 5 here, when I'm using range, is going to be exclusive. So if I'm going to use a check like this, 5 in range, or num in range low and high, I'm going to have to say high +1 in order to be inclusive of both. So let's see what that looks like. I can say the check num in range, and then what we're going to do here is say low, comma high, +1. Now keep in mind, if I just wanted to return the Boolean as shown here, then I simply return this. I'll say return num in range low, high, +1, because I'm checking if this number is within the range between low and high inclusive. That's why I added the +1 there. So if I run this, then I have the Boolean check ready to go. If I want some sort of print statement, then I can simply just use an if statement. I'll say if this happens to be true, go ahead and make some sort of print functionality here. So I can say something like, let me use f-string literals here. Let's say num, is in range of low and high. Then I'll say else print not in range. And you can obviously write whatever you want here, but we run this and we can see 5 is in range of low and high, and if you want, you can keep replacing these with actual low and actual high. So we run that and it says 5 is in range of 2 and 7. And this is just f-string literal printing. We covered that in the print formatting lecture. All right, moving along. Next, we wanted to write a Python function that accepts a string and calculates the number of uppercase letters and lowercase letters. And this is where we're going to have to use a for loop within the function. So I can also make use of a dictionary in order to keep count. So if you feel ambitious, you can also explore the collections module, which is something we cover later on in the course. I'll go ahead and just show you how to solve this given what we already know so far. So the first thing I need to do is figure out something to keep track of the number of uppercase and lowercase letters. So I can have some sort of counter, such as 2 integers that start at 0 and then start counting them, or I can use something like a dictionary. So I'll first show you with 2 separate variables, and then I'll show you the dictionary method. So let's go ahead and say lowercase starts off at 0, and then uppercase starts off at 0. And what I'm going to do is the following. I'll simply say, for every character in my string s, if, and this is where the is upper and is lower comes into play. These essentially return a Boolean if it's uppercase or lowercase. I'll say if the character is uppercase, then go ahead and add 1 to my lowercase, or excuse me, my uppercase count. Whoops. So we'll say uppercase plus equals 1, which is the same as saying uppercase is equal to uppercase plus 1. And then I'll have another check here. I'll say elif character is lower, then go ahead and say lowercase plus equals 1. And then finally, if I say else, so for example, I could have punctuation. If we take a look at the result of that, let me add in a cell here. If we have the string question mark and I say is upper, it's going to say false. But if I also say is lower, then it's also false, because technically a question mark isn't really uppercase or lowercase, which means there's going to be a third option here where neither of these happens to be true. And if that happens to be the case, I will simply pass. So I'm adding 1 to the count if it's uppercase, or adding 1 to the count if it's lowercase. If I happen to have punctuation there, I'll simply pass. Once this entire for loop is done, I can print out the results as shown here. So we want to make sure that we align this with the for loop, so our for loop executes first, and I will go ahead and print out the original string. So we'll say original string, and then it was just s, print out lowercase count. That's going to be lowercase, make sure we have an f string there, and then finally print out uppercase count. Uppercase count will then just be uppercase. So we run this, let's check if it works. And it looks like we got the same results. I accidentally flipped this, so it's lowercase 33, uppercase 4, but that was the same as here, uppercase 4, lowercase 33. So it looks like this is working correctly. Now I mentioned you could also do this with a dictionary. If you're dealing with lots of things to keep track of, it might be helpful that instead of all these being separate variables, you just transform this into a dictionary instead. So what I mean by that is setting up a dictionary, so we'll just call it dictionary D, that happens to have key values. So we'll say upper 0, lower 0, and then instead of having lowercase and uppercase here, we simply take the count at that key. So we'll say D upper and D lower. And when you start to get things that are more complex or larger, it becomes really nice just to have this single object you can reference with these key calls. And then we simply need to swap this out, lowercase and uppercase, for D upper and D lower. Make sure you keep an eye on what kind of quotes you're using, otherwise you'll get an error. So since I'm using single quotes on the outside, I'll use double quotes here on the inside. So this is going to be lower, and then in here we'll say this is upper. There we go. So we go ahead and run this, and we get back the exact same results. Up to you, both methods are correct. I personally prefer this sort of dictionary method. Okay, let's go ahead and continue. Next task was to write a Python function that takes a list and returns a new list with the unique elements of the first list. So basically, we just want to get rid of the repeats. Now, there's one very quick way to do this, which is to simply return, if you say set list and run this, that returns the set, which means I can then easily transform that into a list by casting it into a list, and there you have it. This is probably the simplest and most Pythonic way of doing this. However, I do want to show you kind of a more logical and manual way of doing this, just so you can get used to using for loops and if statements within a function. So another way we could have done this is to basically have a placeholder list that then we're going to append items that we haven't seen before. So we'll say for number in that list, if that number is not, whoops, I don't need to say is, not in X. So in fact, let's just call X seen numbers. So if that number is not in the numbers I've already seen, then I will simply say see numbers, append the number. And then once this for loop is completed, I will simply return the list, see numbers. And if I run that, I get back the exact same results. So essentially what I'm doing here is I have this list. It's the numbers I've already seen, starts off as empty. And then for every number in my original sample list, so for 1, 1, 1, 2, 2, and so on, if that number is not already present inside this unique list that I'm building, this see numbers, then I'll go ahead and append it. And then once this entire for loop is done running, I'll go ahead and return seen numbers. Computationally speaking, this is not nearly as efficient as the previous way we saw. So keep that in mind. Now, next is to write a Python function to multiply all the numbers in a list. Later on, we'll actually learn about things like mapping, filtering, and reducing, which essentially are built-in functions in Python that allow you to do this quite easily. But for now, we'll go ahead and do this manually. So what do I need to do? It's actually a really similar problem to what we had here. We're going to start off with some sort of base case, use a for loop to adjust it, and then return that final thing. So what we're going to do here is start off with total equal to 1. And the reason for that being is 1 times anything is going to be the resulting number. So what I mean by that is 1 times n is equal to n. So 1 times 100 is equal to 100, 1 times 200 is equal to 200, and so on. So then all I need to do is for every number, or every num, in numbers, take my total, and then multiply it by the current number. After that, return the total. So again, because we're using multiplication, I'm going to start off the total is equal to 1. If the ask was to add all of these, then I would have started with 0. So we'll say for num in numbers, the total is equal to the current total times that number. So if I run this, notice I get back same results. And if I want, I can keep adding to this. So if I add a 10 here, notice I get negative 240. So this is going to adjust to however long my list happens to be. Next, we wanted to write a Python function that checks whether a word or phrase is a palindrome or not. So how can we do this? We essentially need to do two things. One, the first one, is remove the spaces from the string. And that's because when it comes to a phrase palindrome, notice this space will technically ruin it if we were to immediately reverse this, because we would get NUR space and then everything else. When going forwards, there's technically no space after NUR. So what we should do is remove that space and then check if string is equals, that's double equals there, so check for equality, if the string is equal to the reversed version of the string. Okay, so how can we do this? Well, to remove spaces in a string, we hinted that you should check out the replace method. So really easy to use here. I'm simply going to say s is equal to s dot replace, and I'm going to replace all spaces, so that's quotes with a space there, with an empty string, so essentially no space. So notice here there's a space on this first one, so it says replace all spaces with nothing, an empty string. And I want to show you what the effects of just doing that are. So if I return s here, and I run this, notice it removed the space from nurse's run. Next step is to check if the string, this one, nurse's run without the space, is equal to the reversed version of the string. So lots of different ways you can do this, but if you Google search how to reverse a string in Python, there's kind of a really famous method, which is to do the following. Check s is equal to, and then the reverse is going to be s with slice notation, colon, colon, negative 1. So what is that actually doing? S colon, colon, negative 1 here is saying, starting all the way from the beginning, going all the way to the end, grabbing the string in a step size of negative 1. Recall, we can grab the string in various step sizes. So if we grab it in step size of 2, that means you take a step size from the beginning of 2. So it would be every other letter in this string. If I do a step size of negative 1, that means start all the way at the end and then work backwards. So I can simply return the result of this check. And now when I run this, I get back true or false. So now this works with a full phrase, and regardless of where this space is. So in fact, I can kind of put spaces wherever. This will remove all of them, and this will check if it's actually a palindrome. So note that still returns true. And then finally, the hard one here was to write a Python function to check whether a string is a pangram or not. And you should also assume the string passed in does not have any punctuation. So pangrams are words or sentences containing every letter of the alphabet at least one time. So that's kind of a key word here, at least one time, which means I only need to check if that letter occurs just once. Okay, now there's lots of different ways you can do this. As long as you got the same results as us, don't worry if you did it a different way, but basically you should get true for the quick brown fox jumps over the lazy dog, and false for a sentence that doesn't have all letters of the alphabet. I'm going to show you how you can do this with a simple set comparison. So we'll come back here and we'll plan out what this function is going to do. The way we're going to do this, and keep in mind there's lots of different ways you can do this, is I'm first going to create a set of the entire alphabet. Then I'm going to remove any spaces from the input string. Then I'm going to convert the input string into all lowercase, because what I'm using for the comparison is all the lowercase strings. And then what I'm going to do is I'm going to grab all unique letters from the string. Because recall, I only care that they show up at least once, which means if I have two B's or two A's, I only really care about their uniqueness, that A just happened to show up at least one time. So a nice way to do this would be with a set. And since I'm going to have a set of the alphabet and a set of all the unique letters in lowercase, then I just compare my alphabet set to check if it's equal to my string set from the input. So let's check this out. To create a set of the alphabet, I will call this alpha set and say set alphabet. Next, to remove any spaces from the input string, we actually already know how to do that. It's simply call replace all spaces with nothing. Then we're going to convert them all into lowercase. So that's str1 dot, or is equal to str1 dot lower. And then we'll say str1 is equal to the set of str1. And then finally, we're going to return the check that str1 is equal to alpha set. So let's see what happened here. I created a set of the alphabet with this set, removed any spaces, lowercased everything, then converted it into a set, and now I'm comparing my alpha set along with my string set. So now when I run this, I get back true. And if any of these steps happens to confuse you, a really nice way to visualize things is with print statements. So if you maybe aren't clear what alpha set is, you can simply print it out when you call the function, and when you run this, you'll get to see that entire alpha set along with what is being returned. So you can use that at any point in time. So let's say you're confused what step you're at right after this, you'll simply say print str1, and this is a really great way to learn as a kind of beginner. So now we can see at this point in time, everything's lowercase and there are no more spaces. So I highly encourage you as you're learning to use those sort of print statements to help you kind of debug or understand what's going on in larger functions. All right, that's it. Great job, and I'll see you at the next lecture.